Hello and welcome to this new section, and in this section we will be learning about how to use databases in a Python application. So in this section we will learn how to work with databases, and in this specific lecture we will learn what is a database and why exactly do we need a database. So in order to understand what a database is and why essentially it is required, let's take a simple example. So let's say you want to design a social media website. So while creating that website, a social media website needs to have a data related to the user. Now obviously you first need to accept that particular data or information from the user, just as you would accept from a regular Python console. However, the problem here is that whenever you accept some information from the user in a Python program, that information typically gets destroyed whenever the program ends. However, we want this information to persist, and therefore we need to store that information somewhere so that the information remains there even after the program execution ends. So to make the data persist, we could store it into a file, or we could store it into a database. And we have already learned how to store data in a file in the file handling section. Now a better way to store data is storing that data into a database instead of storing that data into a file. So let's now compare the two options for storing data, which is file versus database. So these are the major differences between storing data in a file and storing data in a database. So data which is stored in a file is unstructured, and data stored in a database is usually well organized. So whenever you save some data into a file, typically that data is not as well organized or as structured as it is in a database. Therefore, we always go ahead and prefer a database to store information more than a file. Database enforce data integrity, and files do not have a built-in mechanism to enforce data integrity. Now, what exactly is data integrity? Let's suppose, for example, you want to accept a user's name and then save that name into a file or a database. Now, in case of a file, what happens is, if the user actually types in his name as 1234, the file has no way to ensure what kind of data it needs to accept. And the file will happily go ahead and accept 1234 as the name of the user, and it will store it. However, with databases, we could enforce a data integrity rules, which means that we could say that, all right, as we want to accept the name of the user has to be in form of a string, and it cannot be a number. So this rule enforces data integrity on the data which we store in a database, which is not possible in case of a file. Therefore, databases are a much more better choice when it comes to storing data, because databases automatically enforce that data integrity. The third point is, data which is stored in a file can only be accessed and manipulated through simple I/O operations. So let's suppose you have some kind of data which is stored in a file. So in order to access that data and manipulate that data, you could do that by simple input-output operations like reading data from a file and writing data to a file. However, the data which is stored in a database can only be accessed and manipulated using SQL or SQL, which stands for Structured Query Language. And this structured query language actually allows us to perform some really complex queries over the database. So whenever you have to access data in a file, that could be easily performed by simple read and write operations. But whenever you are dealing with databases, you need to learn a special language which is called as a structured query language. Now the structured query language is a little bit more complex as compared to the standard read file and write file. However, SQL actually gives you a more powerful way to access and manipulate the data inside the database, and also enables you to perform complex queries on that database as well. And the final point is, databases are optimized for performance, and files can be extremely slow to read. So when you're dealing with a very large amount of data of hundreds of millions of users, then in that particular case, databases are obviously more preferred, as databases are more optimized for performance. They are much faster as compared to reading data from files. So this was the major difference between a file and a database. Now let's focus on the question, what exactly is a database? So a database is nothing but It's an organized collection of structured information or data stored electronically in a computer system. So a database is nothing but it's kind of like an organized collection of structured information. So the data or the information which is stored in the database is highly structured, and a collection of that structured information is a database. Now this is electronically stored inside a memory inside a computer system. And a database is controlled by a database management system. So whenever you use some kind of a database, along with the database, you also have something which is called as a database management system, or DBMS. So this database management system allows you to access the database, create database, and perform manipulations inside that database as well. Now typically, a database and a database management system combined together is called as a database. So remember that whenever we say database from here on, we typically mean the database itself combined with the database management system. Now once we have a basic idea of what a database is, let's now go ahead and understand how data is actually stored in a database. So data in a database is stored in a tabular format. So if you recall, the data inside a file is not stored in a tabular format. It is typically written as we write some kind of text to a file. However, data inside a database is stored in form of a table which looks something like this. Now, a single database can contain multiple tables. So let's say we are creating an application for a school management system, and in that we want to store the information of students, teachers, so on and so forth. So in that particular case, in order to store students' information, we store that information inside of a table which looks something like this. So this right here is a database table, and inside of a database table you have these rows, and then you have these columns right here. And inside a row, or inside each row, we have information related to one student, and inside each column which we have, each column is actually identified by a unique attribute. So for example, as in this case, we want to store the information of a student. A student might have an unique ID, they might have name, age, and they also might have address. So in order to represent this information, we now create columns with respect to those attributes of a student. And then in order to save information related to that student, we create multiple rows inside this table. So right now, this table only contains this single row, which is for John. So John has an ID 1, John's age is 19, and his address is New York. So each row inside our database table represents one entry. So if you want to add another student here, you need to go ahead and create another row here inside your database table. So this is how typically information is stored inside a database. So inside a database, you have a database table, and that database table is represented by rows and columns. So the column inside the database table represents attributes of the data which you want to store. So in this case, as we want to store students' data, the students' attributes are ID, name, age, and address. And the rows which we have up over here, they actually represent the data related to each individual student. So this is how you could go ahead and store information of a student inside a database. So once you have a brief idea about how information is stored inside a database, now let's learn how we could access this particular information from the database. So as I earlier mentioned, whenever you want to read data or manipulate data inside of a database, you need to use something which is called as a structured query language. So let's take the previous example of the student table, and let's say you want to access the information of a specific student here. So in order to access this information, you have to write a special syntax, or you have to use a special language called as structured query language, or SQL. So this is what the syntax of SQL looks like. So here, let's suppose I want to get the age for the person or for the student whose name is Sean. So in this case, I write a SQL statement which would say something like, all right, select age from the student table where the name of the person is Sean. So don't worry if you don't understand this syntax as of now. We are going to learn how this syntax works in the lectures to come. So when you go ahead and when you write this particular statement and execute this, you're going to get an output as 19 because this statement specifically wants to get the age from the student table for the entry where the name of the student is John, and therefore we got the age for that particular student. Now imagine if you have thousands of students here, and out of those thousands of students you want to find the age of a specific student. You could easily do that by writing this SQL query right here. So SQL is also pronounced as SQL as well. So in this lecture, we have learned the major differences between storing data in a file versus storing data in a database. We have also learned how exactly data is stored in a database by using database tables. We have also learned how to retrieve the data from a specific database table as well. So this was just a brief overview to give you an idea about how databases actually work. Now in the next lecture, let's go ahead and let's learn the different types of databases and database management systems. So thank you very much for watching, and I'll see you guys in the next one. Thank you. In this lecture, let's go ahead and let's learn about the different types of databases which are available. So in the previous lecture, we have learned what exactly databases are. So even before diving deeper into learning about databases, first of all, we must understand what are the different types of databases. So there are two major types of databases. One is the relational database and the next one is the non-relational or NoSQL databases. So let's take a brief overview of the differences between these two kinds of databases. So let's first talk about relational databases. So as the name itself implies, relational databases basically mean there is a relation between the tables which we have. So in a relational database, data is actually stored across multiple tables. So in the previous lecture, we have taken an example of a database in which we have a student table, and similar to the student table, we could have multiple other tables inside our database depending upon the type of information which we want to store. And in a relational database, information is spread across multiple such tables. Now, in case of relational database, as I earlier mentioned, as the name implies relational, these tables which we have in our database are related to each other. Now, how exactly they are related with each other, we are going to learn that in the later lectures. But for now, you need to understand that the tables in a relational databases are somehow connected to each other. The next thing about relational databases is that data in a relational database is stored in a row and column fashion. So again, we have taken an example of the student table in which we have a row for every single student and we had columns for every single attribute which the student might have. Next thing is, for a relational database, SQL is used as a primary language for reading, creating, updating, and deleting data. Which means that, let's say if you want to go ahead and read some information from the database, you'd need to use SQL. And the same thing is going to apply for creating, adding the data to the database, updating that data, or deleting data as well. So any kind of operation which you want to perform on a relational database, you have to perform them only and only by using SQL or SQL or structured query language. Relational databases are actually suitable for structured data. So let's say, for example, if you're designing some kind of an application where you have a data which needs to be structured, in that particular case, you should always go with relational databases because they offer a very structured way of storing all of your information. Now, some of the primary examples of database management systems which actually follow this relational database approach are MySQL, and then we have this PostgreSQL. So for this particular section, we will be learning about the PostgreSQL database, which is going to be a relational database. However, you should also understand what is a non-relational database or a NoSQL database. So from the name itself, you could imply that the databases which do not use SQL as a language to access or modify the data, they are called as NoSQL databases. And NoSQL databases are also called as non-relational databases, and that's because here we do not store data in a table, and also those tables have no relation with each other as well. Therefore, they are called as NoSQL or non-relational databases. So they are called NoSQL because they do not require the structured query language as its primary access language. And these databases do not have a predefined structure either. That means whenever you have to use a NoSQL database, you don't have to first go ahead and define the structure for that database. So this might be an advantage or disadvantage depending upon the scenario you have. And as this particular database does not have a predefined structure, it is usually suitable for storing non-structured data. So let's say if your application is going to have a lot of data which does not need to be structured at all, then in that particular case, you could go ahead and go with NoSQL databases. So the primary example of a NoSQL database is MongoDB. So whenever you want to use a NoSQL database and whenever you don't want to be bothered writing structured query language code, in that particular case, you could go with NoSQL databases and you could use MongoDB. All right. So this was the major difference between the two major types of databases which are available in the market, which is the relational database or SQL databases, and then we have the non-relational or NoSQL databases. So in this particular section, we will be learning about the relational databases, and the database management system which we will be using is PostgreSQL. So in the next lecture, let's go ahead and let's learn what exactly PostgreSQL is and how we could use that in order to build Python applications. So let's learn about that in the next one. In this particular lecture, let's go ahead and let's have a brief introduction to PostgreSQL. So what exactly is PostgreSQL or PostgreSQL? So PostgreSQL or Postgres is a powerful open source relational database management system. So let's dissect this statement. So Postgres is powerful, meaning that using Postgres, you could build some really complex web applications, and Postgres as a database management system could support those applications well. Therefore, it's a powerful system. It's open source, meaning that it's actually free to use. And it's a relational database management system. That means it supports tables and allows us to have relationship between those database tables. Now remember that PostgreSQL is not a database, it's actually a database management system. So it's essentially like a software which allows us to create and manage databases. However, to keep things simple, we say that Postgres is a database. It's a popular choice for small-scale applications to large-scale projects. So if you're a startup which wants to build a small application for its users, you could use Postgres. And if you want to build large-scale enterprise-level production apps, in that particular case as well, you could go ahead and make use of the Postgres database. So no matter what kind of a software you're building, if you're building small-scale applications or a large enterprise application, Postgres suits all needs. Postgres is open source, meaning the source code for Postgres is available for free and it can be widely used, modified and distributed. So you could also create your very own flavor of Postgres database management system and you could distribute it and also use it in your very own projects as well. The next thing about Postgres is that it's an object relational database. So what exactly do we mean by an object relational database? So a traditional database only supports simple data types like integers, strings, numbers, floats, etc. That means you could go ahead and store integer values, strings, floating point numbers, so on and so forth. However, in an object relational database system, you could also go ahead and create your very own complex data types as well, or you could basically go ahead and have user-defined data types, and then you could save the data of those types into your database. So essentially, in an object relational database management system, you could go ahead and save objects as well. Now, along with this, object relational databases also include the ability to have object-oriented programming features such as classes, encapsulation, and inheritance. Now, such object relational databases are specifically useful when dealing with apps which have a complex data structure and relationships. So that means if you're building a modern application wherein you need to go ahead and have some really complex objects and you also need to establish a relation between those particular objects, in that particular case, you could go ahead and make use of Postgres. And on top of it, you could also go ahead and make use of the structured query language whenever you have to manipulate that data. So I hope this kind of gave you an idea about what exactly Postgres is and what are its different features. So in order to understand Postgres in a much more better way, let's download and install Postgres on our machine. So in the next lecture, let's go ahead and let's learn how to install Postgres on a Windows machine. And in the lecture next to that one, let's learn how to set it up on a Mac. So thank you very much for watching, and I'll see you in the next one. In this lecture, let's learn how to download and install Postgres on a Windows machine. So if you're a Mac user, then please refer to the lecture next to this one for installation steps for Postgres. Alright, so simply go to Google and search for download Postgres, and over here click on the first link which pops up, which is going to be the official Postgres link. So click on this one, and once you are redirected over here to this particular download page, here you need to select the Windows option right here. So let's click on that, and over here you need to click on this download the installer option. So when you go ahead and select this, it will redirect you to this page which contains installation files for different operating systems. So here we want to choose the latest version of Postgres, which is at this moment 16.2. So make sure that you select the Postgres version 16.2, and here we want to select this particular option, which is Windows x86-64. So as we are using 64-bit Windows, simply click on this one, and this will actually go ahead and download Postgres for you. So I'll save this file up over here, and now as you can see, the download has begun. And once this is downloaded, I'll simply open this thing up and it will start the installation wizard for Postgres. So as you can see, the installation is complete. And now if I open this thing up, so now it will ask you if you want to allow this app to make changes to your device. Simply click on yes. And now as you can see, the installation wizard has opened up. So over here, I'll click on next. This will be installed at this particular location. So click on next. Now from here, you could actually go ahead and uncheck Stack Builder because this is not something that we need. Apart from that, you need all of the other options here. So make sure that they are selected. Click on next, next. And here it will actually ask you to set up a password for your database. So for the password, I'll type in the password as admin123 and admin123. Make sure that you remember this password because we are going to need this password whenever we want to use Postgres. So simply click on next. The port number here is 5432. Click on next. You also need to remember the port number. Click on next, 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 and the installation has started. So once the installation is complete, we will also learn how to open up the PSQL shell, which allows us to access a Postgres database. Alright, so now the installation has finished. So I'll click on finish here. And now what you need to do is you need to open up the PSQL shell in order to go ahead and get started with the Postgres database. So over here on Windows, simply go ahead and search for PSQL. And here, this is the program which we will be using to interact with our database. So simply go ahead and open this thing up. And when you open this thing up, it will actually go ahead and ask you to enter certain credentials. So let me go ahead and zoom in a little bit by increasing a font. All right. And now over here, it will ask you to log in and it will say if the server is localhost. So yes, it is. So I'll simply go ahead, hit enter. It says database is Postgres, hit enter. Port number is 5432. So this is the port number which we have set up during installation. And now it will say the username is going to be Postgres, and then it will ask you for the password. So just recall the password which we have used during the installation. So I'll simply type in admin123. And even if you type in the password, it's not going to be shown up over here. You simply have to hit enter by typing in the password. And as you can see, now we are actually logged in into this PSQL shell. So whenever you have to go ahead and access the Postgres database, you have to do this by making use of the PSQL shell. So you have to open this thing, and every time you want to log in, you need to repeat these steps wherein you have to type in the password and then log in into your PSQL shell. So that's it for this lecture. And from the next lecture onwards, let's go ahead and let's learn how you could create a database into this PSQL shell. So the lectures next to this one are going to be on Mac. However, the steps are going to be exactly the same for both Mac and Windows. So thank you very much for watching, and I'll see you guys in the next one. In this particular lecture, let's go ahead and let's learn how we could install Postgres on a Mac. So simply go to Google and search for Postgres. And over here, you could directly go ahead and click on this particular link for downloads. So simply go ahead and click on downloads, or you could also go ahead, go to Postgres here, which is the home page, and over here, go to the download. And on this particular download page, you need to scroll down a little bit and you need to choose your operating system. So as we are on Mac, I need to select this particular option which says for Mac OS. And over here on this particular page, you have to choose the option which says download the installer. So simply click on that, and then you will be presented with this page which has a whole bunch of options to download different versions of Postgres. So in this case, I'll download the latest version, which is 16.2 as of now. So I'll click on this particular icon right here, and that should download the file for us. So I've clicked on save file, and that will download the DMG file for us. So once this file is downloaded, we simply need to open up this file and go through the installation wizard. So once the file has been downloaded, I'll simply open this installation wizard up. And over here, I just need to open up the package which has now been downloaded. And when you try to open this thing up, it's going to show you this warning. So over here, I'll click on open. And now it's going to ask you for the password. So simply type in your system password here, hit OK. And now the installation wizard has started up. Now, if the installation wizard does not start for you, then what you need to do is you need to go to the settings on your Mac OS. And over here in the system preferences, what you need to do is you need to go ahead and select security and privacy. So over here, you could go to the security and privacy, and it might actually give you an option over here which kind of asks a permission for downloading and installing Postgres. So if it actually asks you for that permission, simply click on the unlock icon here, enter the password, and allow for that particular package to get installed. So once you allow that, now you will be presented with this setup wizard. So simply click on next here. And if you have any problems setting up Postgres, then feel free to post in the Q&A section. Alright, so over here, let's click on next. Let's click on next. Make sure that all of these options are selected. Click on next, next. And over here, you need to type in or set up a password for accessing Postgres. So remember that this password is crucial, and you'll actually require this password whenever you have to connect to your database. So I'll set the password as admin123. Retype the password as admin123. Make sure that whatever password you set in, you actually remember that. Click on next. And over here, you need to select a port number. Now by default, it's showing me that the port number is 5432. And you also need to remember this particular port number as well, because this will be actually required whenever you go ahead and connect to your database using your Python code. So over here, I'll click on next. Click on next. Next, next, and now the installation process has actually begun. All right, so now the installation has been completed. So I'll click on finish. And now once the installation process is complete, in order to open up Postgres, what you simply have to do is you simply have to open up the Spotlight search on Mac. So simply press Command space, open up the Spotlight search, and over here you need to search for PSQL or pSQL. So it will give you an option which says SQL shell in parentheses pSQL. So simply open that thing up. And over here now it's going to ask you for the permission. Simply go ahead and click on OK. And now as you can see, a terminal window would open up which would look something like this. So this right here is your pSQL shell, using which you could go ahead and access the Postgres database and do whatever you would like to. So over here, now let's learn how we could go ahead and log in into this pSQL shell and access our databases. So here it's saying server localhost. So simply go ahead, hit enter. That basically means you're connecting to your localhost server, and this is the server which is going to be serving your Postgres database. Now here it says that the database which we are using is Postgres, and that's actually correct. So I'll hit enter. Now it will say that it's going to start up the database server on this port number, which is 5432. Hit enter. And now it's going to ask you for the username for your Postgres database. So over here, the by default username is Postgres. So I'll again hit enter, and now it's going to ask you for your password. And over here, you need to type in the password which we have used during installation. So the password was admin123. So I'll simply type in that password here. And even if you type in, nothing is going to be displayed here. You just have to type in the password and hit enter. And as you can see, if you get this Postgres equal to hash icon here, that means you are now successfully logged in. Now this basically means now we are connected to the database server and we could go ahead and execute any kind of commands over here. So in the next lecture, let's go ahead and let's learn how to make use of this PSQL shell to create our very first database. So let's learn how to do that in the next one. In this lecture, let's go ahead and let's learn how we could create a database. So in the previous lecture, we have used this PSQL shell and we are actually logged in into the PSQL shell by entering the username and password. But now here, we need to go ahead and learn how exactly we could create a database. Now remember that we have to create a database on our own. This PSQL or Postgres is a database management system, and that database management system actually allows us to go ahead and create and manage databases. So remember that this is not a database. We have to create our database. This is just a database management system. All right, so now let's learn how exactly we could create our database. But even before creating the database, let's learn how we could view the currently existing databases in our system. So when you install PSQL for the very first time, the system still has a couple of databases which are required. So if you want to take a look at those databases, you could simply type in the backslash. So there are two slashes which are available. This is / and this is backslash. So if you type in \L here and hit enter, this will go ahead and give you all the databases which are currently present. So this actually lists out all the databases which are currently available in your system. So you have these three databases right here. So you have the Postgres database, you have template 0 and template 1. Now, what if you actually want to go ahead and create your very own database here? So let's assume we actually want to create a database, and in that database we need to store information of students. So for that we create a database called as studentdb. You could name your database as anything. There's no hard and fast rule so as to follow. So in order to create a database, you have to type in a command which is create database, and then you need to type in the name of the database which you want. So in this case, as we want to store the student data, let's name this thing as studentdb. Now there's one more thing which you need to remember here, and that is whenever you go ahead and create such kind of a statement here in PSQL, you always need to end your statement with a semicolon, and only after that you should go ahead and hit enter. And this semicolon over here actually denotes the end of that particular statement. So now if I go ahead and hit enter, let's see what happens. So it says create a database here. That means the database now has been created. And if you want to check if the database is actually created, you could simply type in \L one more time, hit enter. And as you can see here, we now have our own database, which is studentdb. So now once we have the studentdb here, now we have to go ahead and store some kind of data into this database. So whenever you have to go ahead and work with any kind of database, you first have to select that particular database. So right now, the database which we are working with is the Postgres database, because right before this hash sign here, the name which is being displayed here is the Postgres, and that means we are working with the Postgres database as of now. And if we want to go ahead and work with the student database, you have to specifically choose that database here. So in order to choose that, you type in \C and then type in the name of the database which you want to choose. So here I would type in studentdb, and you don't have to add any kind of semicolon here. You could simply go ahead and hit enter. And as you can see, now it says you are now connected to the database, which is studentdb as the user Postgres. That means now we are connected to this newly created database, and our username is still Postgres. So we as a user Postgres are now connected to studentdb. All right. So once we are connected to this database, now we could go ahead and think upon saving data into this database. So we have already learned that whenever you want to save some kind of data into the database, you always do that by making use of database tables. So you cannot directly go ahead and save some data right into this database. First, you have to create a database table. So now the question is, how exactly would you go ahead and create a database table? So we are going to learn how to do that in the next lecture. But for now, I just want to show you another command here, which is to delete a particular database here. So right now we are into this student DB right here. But let's suppose you want to go ahead and create another database. So let's create a database called as sample. So create database sample, add a semicolon here, hit enter. And now let's view the list of the databases by typing \L. So this gives us a list, and now we have a sample database over here as well. And now let's suppose you want to go ahead and delete that particular sample database. So in order to delete a database, you say drop database and then the name of the database here. So as we want to delete the sample database, I would say sample, add a semicolon here, hit enter, and as you can see, it says drop database. Now, if you go ahead and check the list of the databases, as you can see, the sample database from here is gone. And now we have a list of the existing databases. And also when you get the list of the databases and whenever it says end here, make sure that you hit enter so that you get this particular database name and hash over here. And only here you could go ahead and execute some commands. So once we have learned how exactly to take a look at the databases which are available, how exactly to create a database and drop a database, in the next lecture, let's learn how we could create a database table in our student database right here. So let's learn about that in the next one. In this lecture, let's learn how exactly we could go ahead and create a table inside a database. So as I have earlier mentioned, you cannot simply go ahead and save some data directly into the database, but you actually have to create a table to save some kind of data. So we have created the student database so as to store student information, but then again, you need to go ahead and create a student table to actually store some student information. So now the question is, how exactly would you create some kind of a table in a database? So first of all, you have to ensure that you have selected the student database. And once you have selected that, then let's create a database table here. So in order to create a table inside a database, you use a command which is create table. And then you simply have to name the table as something. So just as we have named the database as student DB, let's name this table as student, because here we want to save a database of a student. So here I would say student. And then after doing this, you use parentheses here. And in this parentheses, you basically need to specify the attributes which you want to save for the student table. So for example, let's say you want to save the student's name, the student's address, age, and let's say phone number, then you have to explicitly mention those fields here. So here I would say, all right, I want to save the name of the student, and after the name, let's say I want to also save the address of that student. So I'll give a comma and add the next attribute as address. Then I would also say I want to save the age of that student as well, and along with that I want to save the number or phone number here, which is all fine and good. However, there's one problem with this, and that problem is our database is not going to understand what type of data we want to store here. So for example, here for name, we want to store a string because name is obviously going to be in alphabets. It's not going to be in numbers. And in case of age here, we want to specify the age in terms of integers. So we explicitly now need to tell the database that, all right, the name which we are creating here, this should be in form of a string or text. The address need to be in the form of a text as well. The age needs to be in form of a number or integer. And this number over here, which is a phone number, now technically it's a number, but you could also save that number as a string or text. So in order to mention the data types here, you simply go ahead and after the attribute, you simply mention the type of data which you want to store for that attribute. So for the name, we want this name to be text. So here I would say this should be text. The address should be text as well. So I would say text. For the age, I want this to be an integer. So the data type for integer is int. And for the number here, I would say this can be text. So once we have this, we are pretty much good to go. Now finally, let's add a semicolon here to end the statement. Now this will obviously go ahead and create a table. However, whenever you create a table and whenever you add certain attributes, you always need to add one attribute which is called as an ID. Now what exactly is an ID? So let's suppose you create this database table, and once the database table for student is created, you could add multiple students in there. But what happens if you have two students and they have the same name, they have same address, they have the same age, and they even have the same number? Now, technically, it's not possible that two students have the same phone number, but let's consider a hypothetical scenario. So in that case, when two students or multiple students have all the attributes same, you obviously cannot distinguish between those two students. So in such cases, what you need to do is you need to identify those two students on the basis of their ID. So there's another field which you need to add here, and that field is called as ID. And the special part about this ID field right here is that this ID field is going to be unique for each and every student which you're going to add in your database. And therefore, as this field is unique, this field ID is called as the primary key of your database table. So here you need to say this is going to be primary key. So you need to specifically mention that this ID which you will be specifying here is going to be the primary key, and the primary key is nothing but it's sort of a unique attribute using which you could uniquely identify a specific row in your database table. Now, another thing which you need to do here is that whenever you create a table, you don't want to be bothered creating an ID for each and every student. So you want that ID to be auto-generated. So if you want to auto-generate ID for every student, you simply type in serial here. So serial here is actually an attribute using which Postgres is automatically going to create IDs for the student, and it's going to create a unique ID for each and every student which you create. So make sure that you go ahead and type in serial here. So now we have this ID field here, and we say that this is a serial attribute. That means it's going to be auto incremented or auto added whenever you go ahead and create a new entry in your database table. Then you have this primary key which states that this ID field right here is going to be the primary key of your entire table, using which you could uniquely identify rows. And I accidentally have hit the upper arrow key, due to which the entire query went away. So let me type that thing one more time. So create table, name of the table is student or students, and then ID is going to be a serial, which means auto increment. This is going to be primary key. Then we have name in the form of text, then address in form of text as well, then age in form of integer, and then number in form of text. And make sure that you add semicolon at the end. Make sure that you double check this particular table before creating and hit enter. And as you can see, it says create table. That means now the table has been created. Now, if you want to make sure if the table is actually being created, simply type in \d. So this is used whenever you want to check the existing tables in your current database. So this will show me all the existing tables which are present in our student DB. So if I hit enter here, as you can see, we have this particular students table created, which is a table, and the owner of this is Postgres, which is nothing but our username. You could ignore the second row right here, which is a sequence. So right now, as you can see, this student table is created. Now, once this table is created, now you might be thinking, how exactly could we go ahead and add some kind of data to this particular table? So adding data to the table is quite easy. You simply need to use a command which is insert into, and then you need to type in the name of the table in which you want to insert the data. So in this case, we want to create a new student and add the data for that particular student in our students table. So insert into students, and then you need to mention what kind of data you need to add. So here I want to add the name, age, address, phone number. So here I'll add a parentheses, and in this parentheses I would say I want to add the name, address, then age, and then the number. Now here we have simply specified the attributes, and now we have to specify the actual values which we want to add for the name, age, address, and number. So here we say values, and then specify the values in another parentheses here. So we want to specify the name, and the data type for name is text. So that means we have to mention that data type in quotations as this is a string. So you could either use single quotes or double quotes here. So I'll type in John here as the name. Then for the address is also text. So let's use quotations for that as well. So let's say the address is LA. And then for the age is an integer, so you don't have to specify that in quotations. So let's say the age is 34. And then for the number is also going to be in form of a string. So I'll use double quotes here and just type in some random number like that. And now let's end this with a semicolon. So this right here is the query, which is going to insert data into the students table. And the reason why we need to mention this particular name, address, age, and number here is because this sequence actually matches up with this sequence. That means if you have something over here, so let's say you have LA over here, then in that case, you need to have address up over here. And if you kind of go ahead and put LA over here in place of John and John in place of LA, then the name of that particular person is going to be LA and the address is going to be John. So this right here is used for specifying the sequence, and then we need to fill up those sequences with these values right here. And also you might be thinking, all right, we have specified each and every field here, but we have not specified this ID as of now. And that's because this ID field here is auto increment and it automatically gets added by Postgres, and we don't have to worry about it. So right now, if I go ahead and hit enter, we are getting an error here which says column John does not exist. All right, so this was because we have actually used double quotes here, and I take my words back. You cannot actually go ahead and use double quotes, at least in PSQL. You have to go ahead and make use of single quotes here whenever you want to enter some kind of data here. So let's replace the double quotes with the single ones here, and let's see if that works. So if I go ahead and hit enter, as you can see, it says insert 01. That means one entry has now been entered into our database table. So now the question is, how exactly can we go ahead and read the data which is currently being added to our database? So let's learn how to read the data from the database table in the next one. In this lecture, let's go ahead and let's learn how we could read the data from the database table. So in the previous lecture, we have added this particular student entry in our database table called as students. Now let's learn how we could read that specific data. So whenever you have to read something from a database table, let's say you want to get all the rows which are present in that particular table. So for that, you type in a command which is select star, and select star basically means select all the rows from a specific database table. So here we say select star, which means select all from, and we want to select everything from the students table which we have. So select star from students, make sure to have a semicolon here and hit enter. So as you can see, as soon as I do that, now we get a table here, which is the students table, and we get the attributes of those particular students table here. So we have the ID here, and the ID is automatically being set to 1. Then we have the name, which is set to John. Then we have address set to LA, age to 34, and we also have the phone number as well. So this is how you could go ahead and get all the data which is present in your database table. Now let's say we want to add one more entry here up in your database table. So what you could simply do is you could simply go ahead, press the up arrow key, and you'll again get this particular query right here. So you could go ahead and make changes in that particular query itself, or you could also go ahead and rewrite this query from scratch. So let's suppose I want to add another student here, which is Rob. So here, instead of John, I would say Rob. Let's say the location is NY. Let's say the age is 23. Let's say the phone number is 8888. All right, so now if I go ahead and hit enter, this is going to create a new student entry in our student database table. So here, if I go ahead and hit enter, it says one row inserted. So now if I again go ahead and want to check if this particular student Rob is added to the database, I could again execute the query, which is select star from students, add a semicolon here, hit enter. And now as you can see, we now have two entries here, one for John and the other one for Rob. So using the select statement, you could go ahead and select any kind of data which you have in your database table. So right now we only have 2 students in our database table, but let's say you have thousands of students here and you want to get the details of a student whose name is John. So here I would say select star, which means I want all the rows from student. And then over here, I want to specify a condition that, all right, I want to get the data, but only for the student whose name is John. So here after the students, instead of ending the statement, here I would say select star from students where the name of the person is going to be equal to John. And now if I go ahead and hit enter, all right, again, the same issue, that is you cannot go ahead and make use of double quotes here. So let's use single quotes, hit enter. And now as you can see, we got the data for John here. So we get the ID, name, address, age, and number. All right. So now let's suppose you don't want to get all the details here for John, but you only want to get John's age. So here we say select, and here instead of saying star, which kind of gives us all the columns, here I would say select age, which is the name of the attribute which we have here. So instead of age, you could also type in name, address, age, or number. But in this case, as we want age, we say select age from the students table where the name of the person is John, add a semicolon at the end and hit enter. Now, as you can see over here, we only got the age for John and we didn't get all the other details. So using the select statement, you could write pretty complex queries as well. So let's say, for example, if you have thousands of students in your database and you want to get all the students whose age is greater than 18. So you could say select star from students where the age of those students is greater than 18. Now, if you go ahead and hit enter, obviously you're going to get these 2 students here because both are above 18. But let's suppose you change this condition to 23. In that case, you're only going to get John here because Rob's age is 23. And we have specified the condition like age is greater than 23. So if you also want to get Rob here, you could add a condition like age is greater than or equal to 23. So in that case, you'd get the entry for Rob as well. Now with the select statement, you could not just write a simple condition over here like that, but you could also go ahead and add another condition over here. So you could say, all right, I want to select star from students where the age is 23. Along with this, I also want to make sure that I get all the students who actually live in New York. So here I specify another condition by typing and then I say the address of the person is going to be in single quotes NY or New York. Now if I go ahead, hit enter, as you can see, I got the result as Rob because Rob is the only person in the database whose age is equal to 23 and address is New York. So this is how you could go ahead and read data or basically query data from the database using SQL statements. Now in the next lecture, let's learn how you could update the existing data which we have in our database table. So let's learn about that in the next one. In this particular lecture, let's go ahead and let's learn how we could update a certain kind of data in our database. So right now, if you take a look at the database table, so if you say select star from students, here we have 2 entries, and let's suppose for some reason you want to update the data of a specific entry here. So the question is, how exactly could you do that? So whenever you have to update some kind of data into your database, you make use of the update query. So whenever you want to update something, you say update, and then you need to mention the name of the table from which you want to update the data. So here we want to update the data from the student table. So here update data from students, and then you need to specify what kind of update you want to make. So here you type in set, and then we say, all right, here, let's suppose I want to change the number for John. So let's say from 99999, I want to change John's number to 777. So here I would say set number equals. So that means the field name here along with the new value. So the new value is going to be 777. And then you need to say, all right, I want to make this change, but I want to make this change in this particular row right here. Now, in order to make this change, you could say, all right, I want to make this change where the name of the person is equal to John. Now, if I go ahead and hit enter, Now as you can see, it says update 1, which means one entry has been updated. So if I say select star from students now, here as you can see, now the phone number for John has been updated. Now let's suppose you want to make an update, but instead of making an update on the basis of the name of a particular person, let's say you want to make that particular update on the basis of an ID. So here we say update students set, and let's suppose this time I want to change the name of the person from John to Jake. So here I would say set the name to Jake. So Jake where, and here I could also say where the name is currently John, but instead of name I would now make use of the ID. So here I would say ID equals, and the ID for John is 1. So I'll specify 1 here, add a semicolon at the end, and when I go ahead and hit enter, it says update 1. So if I select star from students, as you can see, the name of John has been changed to Jake. So this is how you could go ahead and update a certain kind of data in your database. Now let's learn how we could go ahead and delete a certain entry from your database. So let's suppose from this table right here, you want to delete the entry for Rob. So in order to delete that entry, you say delete from, and we want to delete from the student table. So delete from students, where the name of the person is equal to Rob. Make sure to end this with a semicolon, hit enter, and as you can see, it says delete 1. So if we now take a look at the table here, the entry for Rob from here is gone. So this is how you could go ahead and update and delete a certain row from your database table. Now, once we have learned about all the basic operations about creating a database table, adding entries to that database table, retrieving those entries or reading data from the table, updating and deleting data as well. Now from the next lecture onwards, let's start writing Python programs using which we could do all of these operations from our Python code. So let's learn how exactly to do that in the next one. In this lecture, let's go ahead and let's learn how we could write Python code on a Windows machine using a VS Code, and we will also learn how to execute that code as well. So the very first thing which we need to do is we need to download and install VS Code, which is a code editor using which we could write our Python code. So simply go to Google and search for Visual Studio Code. Click on the first link which pops up. And over here, you could simply go ahead and select this option which says download for Windows. So as soon as you click that, it will actually go ahead and download a VS Code for you. So I'll save this into my downloads folder. And once the download is complete, I could simply open this thing up and it will start the installation wizard for us. So over here, make sure that you select I accept the agreement. Click on next, 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 install. And this will go ahead and install VS Code on your machine. Alright, so once VS Code has been installed, you could simply go ahead and finish the installation, and you could uncheck this option right here. So once VS Code is installed, now let's learn how we could go ahead and write a Python code using VS Code. So for demo purposes, I'll go ahead and create a new folder on the desktop. So let's create a new folder and let's call this thing as my projects. Make sure that you do not have any kind of space in between my and projects. Alright. So once we have this particular folder created, now let's open up this particular folder using VS Code. So I'll simply search for VS Code, open up VS Code from here. And now once VS Code is opened up, for the very first time, this is the kind of window which you'll get. So from here, I could simply go to File, and here I'll select the option to open up the folder. And here we wish to open up the folder which we have just created. So I'll click on Open Folder, go to Desktop right here, and open up My Projects. Select this folder, and as you can see now, this folder would be opened up in VS Code. So from here, you could click on this option right here. And now once we have this particular folder, here is where we create our very first Python file. So over here, click on this icon which says New File. And you simply have to name your file as something. So let's name our Python file as demo.py. Make sure that you have the .py extension. And over here, let's write a very simple line of code, which is, let's say, print and hello world. All right, so here as you can see, we have written our very first line of code. Now let's go ahead and let's learn how to execute this line of code. So to execute this, we'll open up the command prompt. So go to the search bar and search for CMD. Open up the command prompt right here, which is a Windows app. And using this particular command prompt, we will be executing the Python code which we have just written. So first of all, you have to go ahead and navigate to this particular folder, which is my projects, because inside this my projects, you have this demo.py file, which is the Python file which we want to execute. So over here right now, you are into your home directory, and in order to go to the desktop, you say cd desktop. And once you're into the desktop, and from the desktop, you want to go to this directory, which is my projects. So here I'll again type in cd, and cd over here means change directory. So let's go to my projects, hit enter. And now once we are in here, now we will be able to access the demo.py file. So in order to view all the files and folders which are present in this particular directory, I could type in dir, hit enter. And now as you can see, here we have the demo.py file. And now in order to actually run this particular demo.py file, you have to type in Python and then the name of the file, which is demo.py. Hit enter. And as you can see, we got the output of that particular program. So this is how you could go ahead and run your Python code using terminal. However, you need to remember that whenever you close this terminal and whenever you open it up for the next time, you again have to repeat the same steps to go to the directory which contains the Python file. So you have to say cd desktop, cd my projects. And once we are in here, you could type in Python. The name of the file is demo.py. Hit enter and the code would be executed once again. So this is how you could go ahead and use a Visual Studio Code along with the command prompt to run your Python code. Now Visual Studio Code also has a built-in terminal as well to execute this code, but we are going to discuss about that later. So that's it for this lecture, and I'll see you guys in the next one. In this lecture, we will be learning how we could use VS Code for writing and running Python code. So I'm assuming that you already have VS Code with you and you already know how to execute code on it. But if you do not know that, then this is going to be the lecture wherein we will learn how to install and set up VS Code and how we could run Python code on a terminal. So this lecture is going to be specific for Mac users. So if you're a Windows user, then please refer to the lecture which is previous to this one. So let's go ahead and let's first understand how we could download and install VS Code. So VS Code is nothing but it's a code editor, and up until this point we have been using PyCharm, which was an integrated development environment. Now PyCharm is a IDE which is specifically meant for designing Python applications, but VS Code is quite versatile and you could go ahead and design and develop any kind of application in it. So in order to download VS Code, simply go to Google, search for VS Code, click on the first link which pops up. And over here, just go ahead and select this particular option which says download Mac Universal. And if you're on some other platforms, you could go ahead and select that. But for now, as I'm on Mac, I'll simply select this. So once you click on that, simply save that particular DMG file in your downloads folder. And once it is downloaded, you simply have to open this thing up and go through the installation wizard. So I'll simply open this thing up. And now if I go into my downloads folder, I will be able to see this particular option here which says Visual Studio Code. Now as I already have this installed, it's saying Visual Studio Code 2. So you simply have to open this thing up. It will ask you if you want to open this thing up, click on open. And now as you can see, Visual Studio Code has now been loaded up on our system. Alright, so now once Visual Studio Code has been installed, let's now go ahead and learn how we could make use of Visual Studio Code to write some Python code. So in order to write some Python code using Visual Studio Code, first of all, we'll go ahead, go onto our desktop, and here I'll create a new folder and simply name this particular folder as, let's say, my projects. And once you have this particular my projects folder, here you could go ahead and create your Python programs. So let's open up this folder using VS Code. So in order to open up VS Code, simply press Command space and search for Visual Studio Code or VS Code. open up Visual Studio Code, and when you open this thing up for the very first time, this is what you'll be able to get. So from here, I actually want to open up the folder which I have created on my desktop right up over here. So in order to open it up, I'll go to File, Open Folder, I'll go to Desktop, and here I'll simply open up this particular folder which is My Projects. And once I open this thing up, now I'll actually get an empty project right up over here. And in this particular folder, we'll create our very first Python file. So here I'll create a new file, and let's name that file as demo.py. And here now, as you can see, we have this particular file with us. Now it's asking us to activate this extension, but we won't do that as of now. So for now, let's write a simple print statement here. So let's say print hello world. Save this particular file. And now the question is, how exactly would you execute the code inside this file? So in order to execute this code, you have to open up the terminal on your Mac. So simply press Command and space on your Mac and search for terminal. And once terminal is opened up, this is what you'll be able to get. So now using this terminal window, we can execute the code which we have up over here. However, the terminal window which we are using, it actually opens up in our root folder, and this file which we have up over here, which is demo.py, is inside our My Projects directory, and this My Projects directory is actually created on our desktop. So here in our terminal, I have to navigate to that particular file. So first of all, I'll go to the desktop. So here I'll say cd, which means change a directory to desktop. So I'll say cd desktop. So now it will take me to the desktop, and over here, the text over here changes to desktop instead of this tilde right here. And now from the desktop, I now want to go into this particular folder, which is My Projects. So here I would say cd My Projects. And once I'm in there, now here I want to check if I actually have this demo.py file. So here, in order to list out all the available files inside the My Projects directory, I would type in ls, hit enter, and as you can see, here we have our demo.py file. And now if I want to execute this demo.py file, I have to type in Python 3. So make sure that you don't type in Python here, but instead you type in Python 3 demo.py. Hit enter. And as you can see, we got the output of this particular program, which is hello world. So this is how you could go ahead and execute your Python code using terminal. However, there's one more thing which you need to remember. And that is, if you close this terminal, and let's suppose you again press Command space, search for terminal, and open up the terminal window the next time, you again have to go ahead and first of all navigate to this particular path where your Python file is present. So here I again have to say cd desktop, then cd My Projects. Then here, once we are in there, I again have to type in Python 3 demo.py, hit enter, and this will actually go ahead and execute the Python code for you. So from the next lecture onwards, we will be making use of VS Code to write a Python code, and we will be making use of this terminal here to execute our Python programs. So thank you very much for watching, and I'll see you guys in the next one. Thank you. In this particular lecture, we will go ahead and learn how we could use Python to create databases and connect our Python code with the database which we have used in the previous lecture. So in the previous few lectures, we have learned how to use the PSQL command line over here to go ahead, create a database, create a database table, and also how to add and insert data into that database table as well, which is all fine and good. But now in real world applications, we actually want Python to be able to perform those actions of creating the database table, adding data, deleting data, so on and so forth. So the question is, how exactly would you do that? So we could obviously go ahead and write in some Python code here, and we could perform some actions. But the main question is, how would you connect this PSQL database right here with your Python code? So whenever you want to connect your Python code to a database, what we do is we make use of something which is called as an adapter. And the adapter which we will be using in this case is Scicop G2. So Scicop G2 is nothing but it's a Postgres adapter for Python. So essentially it's a library which allows your Python application to interact with your Postgres database. So obviously you cannot directly go ahead and write in some Python code to connect to PSQL, because obviously there are two different languages or two different systems. So in order to connect them together, you need to use a third-party library. Now the question is, how exactly could you go ahead and get this library? So in order to go ahead and use that library, you could directly search for that library up over here on Google, or you could also go ahead and search for something like connect Python with Postgres. So let's make a search for scicop g2. And as you can see, this is the library which we are talking about. So let's go to the first link which pops up here. And as you can see, this right here is the Python package which you could download. So here it will give you the project description, as in what exactly this library does. So as you can see, it says scicop-g is the most popular PostgreSQL database adapter for Python programming language. And you could also go ahead and read its documentation as well. And the installation steps for scicop-g2 are given up over here. So you simply have to go ahead and make use of pip to install this particular library on your system. So over here, I'll open up the terminal, and if you're on Mac, simply open up the command prompt. And if you have the psql shell running up over here, you could simply go ahead, close that, and just open up the normal terminal on Mac. So search for terminal on Mac, and if you're on Windows, search for cmd. And once the terminal or cmd pops up, you go ahead and execute that command. So on Windows, you have to type in pip install. That's going to be scicop g2. So make sure that you don't make any spelling mistakes here. So scicop g2. And here in many cases, you will have problem directly using the scicop g2 library. Therefore, it's actually recommended that you use the binary version of this library. So you say -binary. And if you're on Mac, then in that particular case, you have to say pip3. So if you're on Windows, say pip install scicop g2 -binary, and Mac users type in pip3 install scicop g2 binary. So let me go ahead and hit enter. And as soon as I do that, now that particular library will be installed on my system globally. So we are not creating any kind of virtual environment here. We are directly installing this particular package globally so that we could use it in any project on our system. So once we have that particular package installed, now we could go ahead and make use of that particular package up over here in our Python code. Now, originally, scicop g2 was developed for heavily multi-threaded applications. So if you actually take a look at the documentation for scicop g2, you will know that scicop g2 was originally developed for multi-threaded applications that can create and destroy a lot of cursors and make a large amount of concurrent inserts or updates. So imagine for a second if you're actually building a Python application. So let's say your application is being used by thousands or millions of users, and those thousands of users are actually constantly interacting with your application. They are creating accounts, they are making some transactions, so on and so forth. So all the data which is entered by the user, or at least some of the data entered by the user, has to be submitted to the database. And whenever these submissions are made to the database, that means your Python program has to go ahead and connect with the database and perform those operations. Now, what scicop g2 allows us to do is, it actually allows us to handle all of those concurrent database actions simultaneously, so that all of those operations are well managed and they are actually executed on your database. Therefore, whenever you're building a real world application, and if lots of users will be accessing your database at the same time, in that particular case, your application need to support concurrent insert and update operations onto the database. And scicop g2 is the library which serves that purpose. So once this library is installed, in the next lecture, let's go ahead and let's learn how we could make use of that library inside our Python code and connect to the Postgres database which we have. So let's learn how exactly to do that in the next one. In this lecture, let's go ahead and let's learn how we could connect our Python code with the Postgres database using the scicop g2 library. So up over here, I've actually opened up a new project which is called as my project, and this project is actually present on my desktop. So if you have actually skipped the lecture which is previous to the previous one, then in that particular lecture, I have actually covered how exactly you could use VS Code and the terminal to execute your Python code. So if you have not followed that lecture, then feel free to check that out. And from now onwards, we will be making use of VS Code to write all of our Python code. So up over here, I have a file called as demo.py. So for now, let's get rid of the code from here. And the first thing which we need to do is we need to import the library here. So I'll say import, that's going to be scicop g2. Once that library is imported, now we have to make use of a specific method inside this library, which is called as connect. So here we say scicop g2.connect, and connect is the method which allows us to establish a connection to your Postgres database. Now to this particular connect method, you have to pass in a couple of parameters. So you have to pass in the database name, then you have to pass in the username, the password, as well as the host on which you're trying to connect to, along with the port number. So the question is, from where exactly are you going to get that data? So let's open up PSQL for a second. So you don't have to open it up, you just could follow along with me. So whenever you try to establish a connection over here to the database using PSQL, it actually asks you for the host. So the server over here is nothing but host, and by default the local host is set as our main host. So if I hit enter, then it says that your database is actually Postgres. Then it will say that the port number is 5432, then the username is Postgres, and then you type in the password as admin123. And now you're actually connected to that particular database. Now in case of connecting a Python code with Postgres, we have to actually pass in all of these parameters as well in order to establish a connection. So let's go ahead and let's pass those values up over here. So the first thing which we need to pass in is the database name. So the name of the parameter is db name, and here we pass in the database name in form of a string. So over here I would say, all right, the database name in this case is Postgres, but we now want to connect to the student database which we have. So if you actually take a look at the databases which we currently have, here as you can see we have the student DB. So we want to connect to the student DB. Therefore over here I would say connect to student DB. The next parameter is going to be the user. So here we need to pass in the username, and for Postgres our username is nothing but it's actually Postgres. So I could simply pass that name up over here as Postgres. The next parameter which we need to pass in over here is actually the password. So the password is admin123. So here I would say password is admin123. Then let's go ahead and pass in the host. So the host here is nothing but it's actually the local host, and then after the host we need to pass in the port number as well. So in my case the port number is 5432. So here I would say, all right, the host is local host, and then I would say the port number in my case is 5432. So in some cases, or in your case, the port number might be different. So if your port number 5432 is already utilized by some other application, then in that case your port number might be different. But in my case it's this one, so I'll specify this one. And if you have some other port number specified here, then make sure to add that port number here. So now this particular method actually gives us back a connection object. So let's capture that connection object into a variable. So I would say con equals this. And let's try to print up this connection object and see what's in there. So I've saved this code, and now let's execute this code. And if we get some kind of a connection object here, that means our database connection was successful. So let's try to go ahead and execute this code. So I'll actually go to the terminal here. Here inside the terminal, let me navigate to desktop. So cd desktop, cd, that's going to be our folder, which is my projects. So cd my projects, and over here we have the demo.py file. So in order to execute this file, I have to say python3 demo.py. So if you're on Windows, simply type in python demo.py. So this is the way using which you could execute any Python file on your Mac using the terminal, and Windows users could do the same. The only thing which you need to understand is how to navigate to this particular directory. So if you do not know what this means, then please follow the lecture which is previous to this one. All right. So if I execute this, now as you can see, we actually get a connection object here. And as we are getting a connection object here, that basically means we are actually connected to the database. And what happens if one of the credential over here goes wrong? So let's say I type in some incorrect password here. And in this case, if I execute this code one more time, this time we are not going to get any kind of connection object because we were not able to establish any kind of connection up over here. And if I go ahead and fix this back up again, and now if I go back here, execute this code one more time, this time, as you can see, we are actually getting a connection object at a particular address along with the credentials like the username, the password, the student, host, port number, so on and so forth. So now once we get the connection object, that means we were successful in establishing the connection between our Python code and the Postgres database. So using the same connection object, in the next lecture, let's try to go ahead and let's try to create a database table. So let's learn how that could be done in the next one. So once we have this connection object, let's now go ahead and learn how we could make use of this object to sort of perform some database actions. So here the very first action which we wish to perform on the database is to go ahead and create a new database table for us. So if you go to the PSQL shell right here, so let me actually log into the database. So admin 123, and let me select the database which is student DB. And now once we are in here, if I want to take a look at the tables which are available here, I could go ahead and say \d, and now we have a list of tables like the students table. Now let me go ahead and delete this table from here by saying drop table students, add a semicolon here, hit enter, and now the table would be gone. So if I get a list of tables right here, it says I did not find any relations. So once you have deleted this table, now let's go ahead and let's learn how we could write some Python code here to create the database table. So in order to create the database table using your Python code, first of all, you have to go ahead and make use of something which is called as a cursor. So now we have the connection object, which is all fine and good, but whenever you want to perform some database operations, you need to use or you need to have access to a cursor or the database cursor. So in order to create a database cursor, here you simply have to go ahead and say connection, which is the connection object. So con.cursor. And over here, it's actually better if you name this thing CONN, which stands for connection. So we say con.cursor, and this will create a cursor for us. So let's save this cursor into a variable called as cur. And now once we have this cursor, we could go ahead and execute certain SQL queries using this cursor. So I'll get rid of the print statement from here, and let's make use of this cursor to execute a certain command. So whenever you have to create a table in PSQL, we actually went ahead and executed a statement like create table, then the name of the table, then we have specified certain attributes for that particular table. But the problem here is that we cannot directly go ahead and execute that particular statement, but instead you have to make use of this cursor to execute any kind of SQL statement in here. So you say cursor.execute, and using the execute method, you could pass in the actual SQL query which you want to execute here. So let's write in the statement here like create table students. So this is going to be the exact SQL query which we have written before. So here, the very first thing which we need to define here is the ID. So instead of saying ID, let's call it as student_ID. And then we want to say that this is a serial, which means that this field is going to be auto incremented. Then we also want to set the student ID to be primary key. After that, let's specify the next field, which is name. This is going to be a text. Let's specify the next field like address. This is going to be a text field as well. After that, let's specify the next fields, which are age and number. So here, age is going to be an integer, give a comma. Number is going to be text. All right, so once this particular statement ends, you actually have to go ahead and add a semicolon over here as you would do with any kind of SQL command. So make sure that you add a semicolon over here. And once you have this particular query executed, now you could go ahead and run this code. However, there are a couple of things which you need to perform here. And that is, whenever you go ahead and perform some kind of a SQL query, you actually have to go ahead and commit those changes to the database. So in order to commit the changes to the database, you take the connection object and say commit. So this is like saving the changes into the database, and after that you also make it a habit to close the connection as well. So con.close, and that's it. So once this thing is done, now let's go ahead and let's run this code. So whenever our Python code is going to execute this line of code, this will actually create a table for us. So right after this, let me also have a print statement which would say student table created. Let's save this. Let's head back to the terminal here and make sure that you're not into the PSQL shell here, but instead your actual terminal. So here we are in the terminal. Let me clear the screen here. And now if I go ahead and say python3 demo.py, hit enter, as you can see, it says student table created. So let's see if the table is actually created in the backend. So in order to confirm that, I'll now go ahead and make use of the PSQL shell. And for some reason I had actually closed this. So let me log in one more time. Let me select the database, which is studentdb. And over here, if I say \d, as you can see now, a new table called as students is created one more time. So this time we have actually created this particular table, not by writing some code in the PSQL shell, but instead we have actually created that by writing this particular Python code right here. So once we have created the SQL table using Python, in the next lecture, let's go ahead and let's learn how we could add some data to this particular database using Python. So let's learn how that could be done in the next one. In this lecture, let's learn how we could add data to the database. So in the previous lecture, we had written this code, which was to create a database table. But once the database table is created, you don't have to go ahead and keep on creating this multiple number of times. So what we would do here is that we'll actually put this code in a function. So I'll create a function called as create table. And let's place this code inside the function. So let me indent this code inside the function so that it won't be executed. So once you have this function, you could always make use of this function whenever you have to create this table. And you could also refer to the code over here as well to kind of take a look at the table structure. So after this, let me create another function called as insert data. So this function is going to help us to insert some kind of data into this table which is created. So I would say def insert data. And in this particular function, obviously we first need to create a connection object. We also have to create a cursor, and then we have to perform the execute a method on that cursor, and then write the SQL command to actually insert data into the database. So let's do one thing. Let's copy the same code which we have up over here, paste it up over here. Now obviously this code is common to both of the methods, so you could create another method as well, which is going to be connect, but we are going to do that later. For now, let's keep things simple. Alright, so we are only now concerned with this method right here. So first we create a connection, we get a connection object, then from the connection object we get the cursor, and then let's write these statements to insert data up over here. So I'll go ahead, get rid of everything from here so that we have an empty string here. Now let's write in the code to insert data into the table. So here, in order to insert data, we write in a SQL command which is insert into table name. So the table name here is students. So insert into students, and then over here you specify the values in the order in which you want to insert. So let's say we want to insert name, then address, age, and then the number. So I'll simply specify those attributes here. And I want to insert into student these values, and then let's pass in the actual values here. So remember that whenever you have to pass in the values, we have to make use of single quotes here. So I've added a single quote here. Let's add for student as John. Let's say the address is New York, so NY. Let's add the age for John, which is, let's say 30, and let's say the number is 999. So over here I would say in quotations 999. And as this particular value for age is actually an integer value, you could actually remove the quotations from here. So let's remove that and we are good to go. So now this particular query would be executed and the new data for John would be added up in the students table. Alright, so after this, in the print statement here, let's say instead of saying student table created, I would say something like data inserted or data added in student table. So let's save this. And if I want to go ahead and execute this code, then we have to call this method or this function. So over here, I would say call the insert data function. So now this will only execute this code, and this code for creating the table won't be executed. So let me go back to the terminal, and over here, let me execute the code by saying python3 demo.py. So as soon as I execute this, it says data added in the student table. So now let's open up the PSQL shell and see if that data is actually entered into the database. So I'll open up the database here. And over here, if I say /t, we have the students table, which we already had. And over here, in order to check if the data is actually entered inside the students table, I have to perform the SQL query, which is select star from students, hit enter. And as you can see, that new entry for John has now been added. So here we have the student ID, which is automatically added. And then the name, address, age, and number are actually added as we have specified up over here. Now, if I have to make a new entry here, I could go ahead and simply change these values. So let's enter a new student Rob. Let's say the address is CA. Let's say the age is 23. Number is, let's say, 888. All right. So if I again go ahead and run this code, so let me open up the terminal to run this code. It says data added in student table. And then if I actually head back to the PSQL shell here, and if I again execute select star from students, as you can see, now we also have the data for Rob added up over here. Now this is all fine and good, and this is working really well. However, what if you don't want to hard code this data up over here, but instead you want this function to accept data from the user? That means whenever we run our program here, it should actually ask us the value for name, address, age, and number, and it should actually add the values which are entered by us into the database. So let's see how that modification could be done. So over here, first of all, even before actually establishing a connection, let's accept data from the user. So here I would say code to accept data from the user, and let's accept the name. So input, and over here I would say enter name. Similarly, let's also get the other fields as well. So this one is going to be for address, enter the address. This one is going to be for age. This one is going to be for number. So enter age, enter number. All right. So now once we have all of these values with us, now we could go ahead and pass in these values to this particular execute command, which we have up over here. But now the question is, how exactly would you pass in those values up over here? So in order to pass in those values here, you have to go ahead and say insert into students, the sequence like that. And over here for the values, instead of passing in the values over here like that, you actually have to replace them with %s. So you have to replace a value for name, address, age, and number, each one of them with %s over here. So you say %s, comma, %s. So this one is going to be for address, again a %s for age, and again a %s for number. And after that, once this statement actually ends here, you have to actually go ahead, give a comma, and then pass in the values which you have up over here inside these variables. So now we take all of these variables like name, address, age, and number, and we have to pass it up over here. So you pass in name, address, age, and number. All right, so let's save this and let's see if that would work. So let me give it a try, and hopefully there are no errors, and if there are any bugs, then we are going to fix them as well. So let me open up the terminal here. Let's run this code. Let's enter the name as Jake, address as LA, age is, let's say, 26, number is 111. If I hit enter, it says data added in student table. So now let's check if that data is actually being added. So I'll open up the PSQL shell. Let's execute the command select star from students, and as you can see, the data for Jake has been added as well. So the only modification which we have actually made to this code is that instead of accepting the actual values here, we have passed in %s, %s, %s as a placeholder. So these %s which we have up over here are nothing but they are the placeholders for these values. So if you have 5 values here, then you have to have 5 %s over here. And these placeholders are then actually replaced with the values for name, age, address, and number, which we have stored up in these variables right up over here. So when this SQL query is actually executed, these %s placeholders are actually replaced by these values, which are actually entered by the user. So this is how you could go ahead and insert the user submitted data to the database. So in the next lecture, let's go ahead and let's learn how we could update the existing values inside our database. So for example, right now, if you take a look at the database, these are the values which we have in here. So in the next lecture, let's write a program which allows us to edit these values. So let's learn how to do that in the next one. So in this lecture, let's go ahead and let's also write in a function which allows us to update the values which we have in our database table. So the way in which this update function is going to work is that first of all, it's going to ask us to enter the ID of the student for which we want to update the data. So that means we first need to accept the student ID. And after accepting the student ID for the student which we want to edit data for, after that we go ahead and accept the new data which we wish to edit. And after getting all of that data from this code right here, then we basically go ahead, make a connection, create a cursor, and then execute the update statement onto that particular table. So let's learn how exactly that could be done up over here. So I'll go ahead and create a new function here, and let's call this thing as update data. So def update data. And over here, now let's go ahead and accept the student ID. So here I would say input, and I would prompt the user to enter the ID of the student which needs to be updated. So here I would say enter ID of the student to be updated. And now let's save this ID into a variable called as student underscore ID. So after this, now we accept the fields which we want to edit. So in this particular case, instead of just selecting a field, we'll actually try to update all of the fields here. So I'll copy this code and accept the name, age, address, and phone number of the student newly. And once I have accepted that, the final thing which we need to do is we need to make a connection. So here, let's copy the code for making a connection and creating a cursor. And let's also get the code for executing the query as well. So the only thing which we are going to change here is we are going to go ahead and update the SQL statement. So I've pasted this particular execute command, and now instead of inserting data, here we want to update the data. So let's write the query for update. So let's delete everything from here. And over here, I would say that, all right, I want to execute a command which is update, and I want to update the students table. So here update students, and here I now have to mention what kind of data do I have to update here. So in this case, we are trying to update all of the entries like name, address, age, and number. So here I would say, all right, I want to update students, and I want to set, so set is also a keyword here. So I want to set the name equals something, then I want to set the address equals something, then age equals to something, and then the number equals to something. So this is what I wish to do here. Now over here, let's go ahead and let's add some placeholders just as we have added up over here. So here I'll use %s. So here I would say I want to set the name to %s, address to %s as well, age to %s, and the number to %s as well. So after this, I want to set these values, but now the question is on which particular row do I want to perform this operation? So here I want to say that, all right, I want to replace those values where the student ID, so student ID is going to be nothing but it's actually our first field, which is this field right here, which is our primary key. So whenever you want to update something, it's always better that you make an update on the basis of the primary key. And the reason for that is because, let's suppose if you have 2 students in your table whose name is John. So if you wish to go ahead and update the data for John, then the data would be updated for both the Johns which you have in your database table. However, whenever we make use of an ID is a unique attribute and two rows cannot have a same ID here. Therefore, whenever you want to update a single row, always make sure that you do it on the basis of an ID and not on some other attribute. Alright, so over here I want to update these fields where the student's ID is going to be equal to, again, something. So here equals to the placeholder %s. So now the query is formed, and now the only thing which we need to do here is that we need to pass in the placeholders for name, address, age, number, and then the student ID. So I'll simply give a comma here and create a tuple. And in this tuple, I simply have to pass in the values for the name, address, age, number, and the student ID. So we get all of those values from here, from these particular variables which we have. So we only have to pass in those variables here. And make sure that you follow this proper order here, or else you're going to get an error. So first is the name, then the address, age, number, and then the student ID. So remember that these values which we are passing up over here as tuples are nothing but these values which are accepted from over here. So this actually forms our SQL query, and this query now gets executed. Alright, so now once the query is executed, we have to commit those changes to the database. So con.commit, and then close the connection by saying con.close. Alright, so now once this thing is done, let's go ahead, save this. And for now, I'll open up the PSQL shell. And over here, I would first check the students table. So let me choose the student DB. Now select star from students. And now over here, let's say we want to change the data for Rob. So I'll go ahead and run this code. So I'll open up the terminal here. So over here, I'll go ahead and call in the update data function. So if I go back to the terminal here, and if I run this code, python 3 demo.py, it's going to ask me for the ID of the student to be updated. So here we actually want to update the data for Rob, and Rob's student ID is 2. So over here I would say 2. Let's change the name of Rob to Robinson. Let's say his address is ABC. Let's say the age is 100, just to kind of make it notable. And then the number is, let's say, 111. So if I hit enter, now the data is updated. And in order to make sure if the data is updated, let's go back over here to the PSQL shell. Let's execute this command one more time. And as you can see, now the data for Rob has been updated. So the name is now Robinson, address is ABC, age is 100, and number is 111. So this is how you could go ahead and update all the values of a given row inside of a database table, which is all fine and good. But now let's say you don't necessarily want to go ahead and update all of the data for a row, but instead you only want to update a certain selected attribute. So let's suppose you only want to update the name, or you just want to update the address, and you don't want to touch the other data which we have up over here. So let's learn how exactly that could be done in the next one. In this lecture, let's go ahead and let's learn how we could enhance the update functionality. So right now, the way in which the update functionality works is that you could go ahead and select any student, and you have to update all the fields of a given student. However, let's say you only want to update name, or let's say you only want to update the age of a certain student, then we don't have that option as of now. So let's go ahead and let's add that feature in our application. So let's go inside the update data function, which we have up over here. And over here, right after accepting the student ID, which needs to be updated, let's go ahead and let's give the user certain options so that the user could actually go ahead and tell that, all right, I just want to update the name, age, address, or the number. So in order to give these options here, let's create a dictionary here for those options, and let's call those options as fields. So the different fields which we have in our database are going to be name, age, address, and number. And let's say if the user actually chooses one option, then they could go ahead and enter the name, age, address, so on and so forth. So here I'll create a dictionary called as fields, and here we will have a key value pair. So the key for the dictionary or for one option here is going to be a number. So for example, let's say if the user wants to update the name, they should type in the option as 1. So option number 1 says that, all right, I now want to go ahead and update the name. So here for the value pair, instead of creating a string here, I'll go ahead and I'll actually create a tuple here. And inside this tuple, I'll say name, which means that this is the option to update the name. And after this, the next pair of thing which I'm going to store here is the message which is going to be displayed to the user. So let's say here when the user selects name, we want to display a message like enter the name. So here I would say enter name, or I could also say enter the new name. So this right here is one of the key value pairs in our dictionary. Now similar to this, we also have to create the key value pairs for address, age, and number. So that means over here I'll say number 2 is going to be another tuple here, and in this tuple is going to be for accepting the address. So it would say something like enter the new address, and let's go ahead, give a comma, and let's create a couple more options here for accepting the age and the number. So I'll copy this option, paste it over here. This is going to be our option number 3. This is going to be for the age, and then the option number 4 is going to be for the number. So this data structure right here is the custom data structure which we have created. So this is like a dictionary, and in the dictionary we have the key value pairs. Now instead of saving the key value pairs in terms of strings, we have saved the key in terms of a string. But for the value pairs which we have up over here, we have actually created tuples for them. And the reason why we have created tuples here is because we want to store the actual field name as well as the message. So let's go ahead and let's change this thing to age and this one to number. All right. So now this particular data structure is created. That means now we don't have to go ahead and ask the user to enter all of these values here. So I'll go ahead, get rid of that. Now here we'll ask the user to choose from these options which are available. So here I'll add a print statement, and this would say something like, which field would you like to update? And now let's present the user with all the fields which we have up over here. So in order to print up all the fields here, we would actually need to loop through each and every field which we have. So here I would say for key in the fields dictionary which we have, I want to loop through everything, and here I actually want to print the field name along with the option right up over here. So over here I would say, all right, print the key as well as the option right here. So here we want to display 1 name, 2 address, 3 age, and 4 number. So first of all, I have to print up the key value which I have here. So let's create an f string here, and inside the f string, first of all, I have to get access to the key. So here I'll simply say key. And then after getting access to the key, then I actually want to print up this particular thing right here. So in order to get access to this, what I need to do is I need to go ahead and say fields, which is nothing but our entire dictionary, and then fields of key. So this fields of key is going to give me access to every single key which I have, and inside that key I actually want to go ahead and access this particular tuple value here. So in order to get that value, this is the 0th element inside the tuple, and this is the first element inside the tuple. So here I would say key of 0. So that would actually give me the first element which we have up over here. All right. So now let's see how that would work. So let's go ahead and let's run this code and see what kind of data would be displayed here. So let's open up the terminal here. Let's run the code, and it says enter the ID of the student to be updated. Let's say I type in the ID as 1. And here, as you can see, it will now print up these options right up over here. Now, obviously we have some errors over here because we have not written the entire code. All right, so these options are now being displayed here, and that's exactly what we wanted as well. Now we want to go ahead and accept the value from the user of these options. So let's say if the user wants to update the age value, then the user is going to type in the value as 3. And when the user actually types in that particular value, then we want to present them with a specific option. So let's go ahead and do that. So let's accept the input value from here. So right after presenting the user with these fields, let's actually accept the input value. So let's use the input function and let's say enter the number of the field you want to update. Let's save this into a variable called as field choice. And now once we have this particular choice with us, now we could go ahead and check if that particular user entered choice is present in this particular field. And if that particular choice is present, then we need to go ahead and accept the value for either the name, age, address, or number. So let's write that logic up over here. So first of all, we'll check if the choice which is entered by the user is actually present in this fields which we have here. So here I'll say if field underscore choice is actually present in fields. So if it's actually in there, in that particular case, I want to go ahead and I wish to get the actual choice. So let's say, for example, if the user enters the number 3, then we want to go ahead and get this value and this prompt which we have up over here. So that means we need to get the field name which the user wants to update along with the prompt which would be displayed to the user. So in order to get access to this, I would say field underscore name. So let's create a variable called as field name and another variable called as prompt. And the prompt is nothing but it's actually the message which we have up over here. And now in order to get those values, here I need to access the fields dictionary. So we have fields here. So over here I would say fields of, and then I want to only access a particular value. So if the user enters the value as 2, I only want to access this value right here. So here I would say fields of 2, and the value 2 is now actually stored inside this field choice variable. So here I would say fields of field choice. So I hope this logic is actually making sense. So now this will go ahead and say fields of 2 is this entire thing. Then this will take the field name, and the field name would be address. So address would be stored inside field name. And then the enter the new address would be stored inside this prompt which we have up over here. Now one thing which you could do is you could also check if that's actually performing well. So you could say print, and let's print up the field name, and let's also print up the prompt as well. So comma prompt. So let's see if that would work. So I'll go ahead, go back to the terminal, run this code. And over here, let's say I want to change the age. So I'll type in 3 here. And as soon as I type in 3 here, as you can see, it will display age, which is nothing but our field name, and then the prompt, which is enter the new age. That means this code is working absolutely fine. All right, so let's get rid of this line from here. And now once we have this particular field name, and once we actually have the message prompted to the user, now we wish to go ahead and ask the user, all right, you want to update the age here, but now tell me the new value which you want to update. So let's capture that new value. So I'll say input, and in this input function here, we wish to display this message like, all right, enter the new age. So here I'll say prompt, because that message is stored inside the prompt variable. So prompt, and then let's save this particular thing into a new value variable. So new value, which means the value which the user wants to update. So this is going to store the new value of age. And now once that value is stored, then we actually want to go ahead and make a database connection and execute this particular update query right here. So to keep things simple, what you could do is you could take all of this particular cursor code and kind of add it before to this one. So you could go ahead and place that code up over here so that the connection is established first. And then over here inside this if statement, you simply have to execute this cursor.execute right up over here. So let's cut this statement and let's actually go ahead, add that statement up over here. All right. Now the problem with this statement which we have here is that it will actually go ahead and update all the values, but we do not want to update all the values, but we instead want to only update the value of the field name which we have here, which is in this case age, as we have entered the input as 3. So the question is how exactly to do that. So here, instead of hard coding this particular query like that, we actually have to go ahead and make this particular query dynamic. So in order to make the query dynamic, let's first go ahead and take this query. So I'll copy this entire string from here. So let me copy that. And let's create a brand new string here. So I'll say SQL. This is going to be an F string because we want the string to be dynamic. And here I'll simply paste this entire query. And let's make a couple of changes here. So I guess we have 2 quotation marks here. So let's get rid of them. All right. So here what we wish to do is we wish to say update students and set not the name, address or age, but instead we want to set the field name. So here instead of name, address and age, let's cut that. So I'll delete all of the 4 fields from here. And I want to set the field name. Now field name is a dynamic variable value. So therefore I'll make use of curly braces here. So set the field name to %s. So %s here is nothing but it's a placeholder. All right. So here we want to set the field name value where the student value is also a placeholder. All right. That's all fine and good. Now we actually want to go ahead and get the actual value entered by the user. So the value is actually stored inside this new value variable. So over here, instead of having these fields here, like name, address, age, and number, now we will add the new value field here. And the student ID field is going to remain the same because we actually need the student ID here. So this right here now is our dynamic query. So it says we want to update the students table. We want to set the field name, which is our field name accepted from the user, to %s, where the student ID is going to be %s. So we are going to get this new value from here. And then we are going to get the student ID from here. And also we are going to get this field name value from our fields array from the user's choice. So I hope this actually makes sense. All right. So now once we have this query, now we actually have to execute that query instead. So over here, what you have to do is you have to cut this entire thing and say, take the cursor and execute this new query which we have. So I'll simply type in SQL. But now the problem here is that this query which we are writing up over here, this should be purely a string, but now instead we have these tuple values here. So let's get rid of these tuples from here and make sure that you only have one double quote here. So now this query is nothing but it's simply a pure string. And then once this query is passed, you could pass in the tuple values up over here, and that's all fine and good. So remember that whenever you have to construct some kind of a dynamic SQL query like that, you go ahead and make sure that that query is a pure string. It does not have any kind of tuple values there. And now these %s placeholders are going to be substituted in this cursor.execute command. So now once this thing is done, we also want to give the user message that, all right, the field which you wanted to update is updated. So here I'll again say print, create an F string here and say the field name. So in brackets, field name, get out of the curly braces and say is updated successfully. Now, along with this if, let's also write an else block for this one as well. So let's say if the user actually enters an invalid choice, then we want to say something like, all right, this is an invalid choice, and that's it. So let's see if this would work. So I'll save this code, open up the terminal. Let me clear the console here. Let's run this code. So it says enter the ID of the student to be updated. So let's go back to our PSQL shell once, and up over here, let's say we wish to change the age for the person Jake. So Jake's ID here is 3. So let's go back to the terminal here and say, all right, I want to update the person whose ID is 3. I want to update the age. So I'll add the option as 3. I'll add the new age as, let's say, 39. If I go ahead and hit enter, it says age updated successfully. So let's see if that actually happened. So let's open up the PSQL shell one more time. And up over here, let's say select star from students. And as you can see, now the Jake's age was 26. Now it has been updated to 39. So now let's see if this also works for some other field as well. So now let's try changing John's name to Johnson. So over here, I'll go ahead, execute this code one more time, enter ID, which is 1. Let's change the name. Let's add the new name as Johnson. And it says name updated successfully. So I could go back here, run this code, run the command, and as you can see, now the name of John has been updated to Johnson. That means now this update functionality is working absolutely fine. So this is how you could go ahead and create a dynamic functionality wherein you don't have to update each and every single detail inside a specific SQL table, but you could only go ahead and update the field which you want. So that's it for this lecture. And in the next lecture, let's implement the final functionality for our application, which is the delete functionality. So let's learn how to implement that in the next one. In this lecture, let's go ahead and let's implement the delete functionality. So in order to implement the delete functionality, let's create a new function here. So let's call this function as delete_data. So the way in which this function works is that, first of all, we'll actually go ahead and ask the user to enter the ID of the student which they want to delete. So let's first prompt the user to enter the student ID. So here I would say student_ID is going to be input. Enter the ID of the student you want to delete. Let's accept that ID. And once we have this particular ID, even before actually deleting the data from the database, you have to confirm if this particular student with an ID actually exists. So therefore, first you have to connect to the database. So let's get the database connection code from here, from the update function. So this code is going to be the same. So let's make use of that up over here. And now, once we have this code, let's now make a search if this particular student actually exists. And in order to find out if this student exists, you execute a SQL query. So in order to execute a query, you say cursor.execute. And then the query which we want to execute here is select star, which means select everything from the students table which we have. And here we only wish to select one single row from the student table. So here we say where the student_ID is going to be equal to, let's say %s, so %s, and then here we actually want to pass in the student ID. So we want to compare the student ID with the student ID which we get from here. So let's pass that student ID here inside a tuple. So student_ID. Now as this is a tuple, you actually need to go ahead and give a comma even though you do not have any kind of values up over here. So make sure that whenever you have a single value inside a tuple, you always end that with a comma so that Python understands that this is a tuple. So now once this query would be executed, it will go ahead and give us back some result, and that result is going to be the single row of that particular student whose ID actually matches up with the student ID provided right here. So now the question is, how exactly would you go ahead and get that row? So whenever you want to get the row after kind of executing the query, you execute a command which is cursor.fetch1. So this will give us back an entire student row. So let's save that student row into a variable called as student. So now once we have that student row, even before deleting that particular row for student, we first have to make sure if that student row actually exists. So here we say if student, that means if this row exists, the value of this would be true. And if there's no row returned by the SQL command, then in that particular case, this is going to be false. So even before deleting the student, we first want to say, all right, we have found the student and these are the details for that particular student. And then we want to ask for confirmation. So here we say, we have found the student and these are the student details. So in order to display the student details, I would say print. And then I would use an F string to say something like student to be deleted. And let's display the student ID. So in order to display the ID here, we have to make use of this student row which we have. So this student row is nothing but the row which you would get by executing this command, which is select star from students. So let's go ahead and let's open up the PSQL shell and let's try to execute that command, and the query should be select star from students, where the student underscore ID is going to be 1. And as you can see, we got this particular row right here. And now in order to access the student ID, as we are getting this row, I have to say student of 0. So student of 0 is going to give me this value. Student of 1 is going to give me the name value. Student of 2 is going to give me the address, so on and so forth. So here, in order to get the student's ID, here I have to say, all right, student of 0. So this will give me the student ID. After that, let's give a comma, and we want to get a name here. So the name value is going to be student of 1. After this, I want to get the address. So the address is going to be student of 2. And then let's get the age of the student as well. So age is going to be student of 3. And that's it. Once these values are displayed to the user, then we want to go ahead and ask the user for confirmation. So here I'll again add a prompt which would say something like, are you sure you want to delete the student? And let's give 2 options here. So yes or no. And then let's accept this choice here. So here I would say choice or confirmation is this. And then if the choice is equal to yes, in that case I want to delete the student, or else I don't want to do that. And also, let's say if the user actually types in the choice in capital letters, let's make a provision to convert this choice into a lowercase letter even before it's actually compared with yes. So if the choice is yes, in that case I want to delete the student. And in order to delete the student, we have the delete command. So here, let's execute the SQL command. So cursor.execute, and here I want to say delete from students table, where the student underscore ID is going to be %s. So this is a placeholder. Let's add the actual value of student ID here. As this is a tuple, add a comma. So after this, I want to say the student record is deleted. So print student record deleted. Or else if the choice is no, then I would say deletion cancelled. So print and say something like deletion cancelled, and that's it. Now once we have the else statement for this if, let's also have an else statement for the outer if as well. So here, if the student does not exist, then I want to say something like the student is not found. So print student not found, and that's it. Once this is done, I also want to make sure that I commit the changes to the database and I close the connection. So here, connection.commit, and then connection.close, and that's it. All right, so once this thing is done, now we are pretty much good to go. So let's see if that would work. So over here, let's call the delete data method. So let's remove the update one, and this is going to be delete data. Let's call this function. Let's execute the code. So let's open up the terminal first, and here python3 demo.py. All right, we have some error up over here, and it would say something like unterminated string literal. So we have this error on line number 30. So let's check that up over here real quick. So on line number 30 right here, I guess we have forgotten to end the particular statement. All right, so up over here, I have actually included a quotation mark, which should not be the case. So if I remove that, hopefully the error would be fixed. So if I run this, enter the ID of the student you want to delete. So let's take a look at our database first. So I'll go inside the PSQL shell. Let's do select star from students. We have 3 students here. Let's say we want to delete Jake. So here I'll provide the ID as 3. So here I'll provide the ID of the student as 3. So now the details for Jake have now been presented here. So it says that the student to be deleted has an ID 3, the name is Jake, and address and age are these. So do you want to delete, yes or no? So if I type in yes here, it says student record deleted. So let's see if the record has actually been removed from the database. So let's execute the select star from students. And as you can see, the data for Jake has now been gone. And also if you now try to go ahead and delete the student with an ID 2, so I could execute this ID 2, and let's say this time I say something like, all right, these are the student details, but I do not intend to delete that. So if I say no here, it says deletion cancelled and the data won't be deleted now. So if I go back here, run this, as you can see, the data for Robinson is now not deleted. So this is how you could go ahead and implement the delete functionality inside your application. However, now the major problem is our application actually contains all the functionalities like create student, delete student, update student, and view student, so on and so forth. However, right now we are only able to execute a certain functionality by just calling that function up over here. Now let's go ahead and let's write a logic in a way that the user actually has an option to choose from the different things they could do with the data. So we want to present a menu here which allows the user to create a table, insert data into the table, read data, update data, delete data, so on and so forth. So let's implement that functionality in the next lecture, and that would make our application complete. So let's learn how to do that in the next one. In this particular lecture, let's go ahead and let's create a menu for our users so that they could go ahead and perform the creation, updation, or deletion of the data. So in order to create that particular menu, we will first go ahead and go right outside all of the functions which we have. And over here, we'll create an endless for loop, and that for loop is only going to end whenever the user wants to quit it. So here I'll say while true, which means that all the code which is written inside here is going to execute infinitely. And here we will give the user certain options to choose from. So here I would add a print statement, and I would say like, all right, welcome to the student database management system. And as I want to print this on a new line, I'll use \n here, and this will actually print this line on a new line. Now here, let's present the user with the options to create table, insert data, read data, update data, and delete data. So here I'll add a print statement, and this would say something like create table. And similarly, let's also present the user with a whole bunch of other options as well. Now you could write these options in a single line by using this /n, and that will print the new option on new line. However, to keep things well formatted, let's have a one print statement for every single option here. All right, so this is option number 2. This is for inserting data. So this would be insert data. This one would be for, let's say, reading data. So read data, update data, and delete data. Now let's add update data and delete data. So this is update data. This one is going to be for delete data. All right, and let's have the final option, which is option number 6. So whenever user types in 6, the application should quit. So this is for exit. So now let's ask the user to enter the choice. So here I would say input to accept the user's input, and we'll add a prompt like enter your choice, and we'll ask the user to enter choice from 1 to 6. And now once the user enters their choice, let's save it into a variable called as choice. Now we wish to go ahead and we wish to execute different kinds of code depending upon this choice which we have. So here you could use a switch case statement, or you could also go ahead and make use of simple if statements as well. So you could say if the choice is equal to 1, that means I now want to go ahead and create the table. So in order to create the table, I have to call the create table function. So I'll simply go ahead and include a function call here for create table. Similarly, over here, elif the choice is equal to 2. In that particular case, I want to do something else. Now, one more thing which you need to remember is that these choices entered by the user inside the choice variable is going to be in form of a string. That means you have to include these in single or double quotes. All right. So here, if the choice is 2, we want to insert data. So I'll call the insert data function. Again, let's type in elif choice is equal to 3. In that case, I want to go ahead and perform the read operation. So here I would say read data. And I think we do not have a function for reading data as of now. So we have create table, insert data, delete data, update data. So let's also include a function for reading data as well. So the read data function only has to get all the data from the database or from the student table and then display that data to the user. So let's create that function here. So def read data. And as usual, let's go ahead and establish a connection with the database. So let's copy this line from here. And let's create a cursor as well. And then once the cursor is created, let's execute a SQL command. So here I would say cursor.execute, execute the select star from students command. Make sure to add a semicolon over here as well. And now once this command is executed, it will go ahead and give us back a whole bunch of rows, that is all the rows of students. So in order to get all of those rows, here I would say students is equal to cursor.fetch all. So we have used this fetch one method, which actually fetches only one row. But if you want to fetch all the rows, you use the function which is fetch all. So once we have all the students here, let's display those students. So this students which we have here is actually a list of rows, or it's actually a list of students or rows. So here I would say for every single student in the students list which we have up over here, we now wish to go ahead and print the details for each and every single student. So here I would say print, and let's create an F string here. So let's first display the student's ID by saying student of 0. So this is the same exact thing which we have done in the delete method as well, which is this line of code right here. So we have to repeat the same thing over here as well. So student of 0 is going to give us the student ID. Then let's get the student's name. So name is going to be student of 1. After that, the address is going to be student of 2. Then the age is going to be student of 3. So this will display all the values to the user. And finally, we have to close the connection. So con.close. So we have the read data function as well. Now we simply need to call that on option number 3. So here I would say read data. Now elif, if that's not the case, and if the choice of the user is equal to 4, in that particular case, I would call the update data method. Elif choice is equal to 5, then call the delete data method. Or else if the choice is 6, then I want to go ahead and end this particular loop which I have. So elif the choice is equal to 6, and then in that case, I wish to go ahead and exit out of the program. So in order to exit out of the program, I have to exit out of this while loop which I have. So in order to quit this while loop, I need to use the break statement. So you simply have to call break here. And if that's not the case, that means if all of these options are false, that means if the user actually enters any choice which is out of 1 to 6, then we want to say that the user has entered an invalid choice. So print invalid choice, please enter a number between 1 to 6. So let's save this, and now let's execute this code and see how this would work. So let's get back to the terminal here. And right now we don't need the PSQL shell because now we have an option to display the details of a table. So right now I could go ahead. Let's clear the console here, execute the code. So now it says welcome to the student database management system. We already have created a table, so we don't have to do that. So first of all, let's try to read the data. So option number 3. Now, as you can see, it says that we have these 2 students, and after that, it will display the students. That function would be called, but since we are in the infinite for loop, it will again go ahead and present us with this option right here. So let's say if I now want to insert a new kind of data, I'll say option 2. So now it would say enter the name. Let's say Jake, address is, let's say London. age is, let's say, 21. Number is, let's suppose, 888. And as you can see, it says data added in student table. So if I want to read that, I'll again say option 3. So now as you can see, the entry for Jake has been added as well. And I guess we actually forgot to add the number over here. So you could simply go ahead and say students of 4, and that's going to display the number as well. Now let's try to use the update data method. So let's say we want to update the data for Johnson. So choice is 4. Now it says enter the ID of the students to be updated. So Johnson's ID is 1. So I'll say 1. Now it would say which field would you like to update. So I want to update Johnson's age. So the field is number 3. I'll say the new age is 25. And now the data has been updated. So let's read the data one more time. And as you can see here, Johnson's age has been updated to 25. Now let's check if the delete data works. So let's delete the data for Johnson. So option number 5 is for delete. Delete the ID where ID is 1. Now I'll say yes, I want to delete. Now if I read the data by typing in 3 here, as you can see, Johnson's data is now gone. And finally, if I want to go ahead and exit this program, I need to say 6. So if I say 6 here, hit enter, as you can see, now the program execution has stopped. So that actually completes our entire CRUD functionality, or the application which performs all the CRUD functionality, which is to create data, read data, update data, and delete data as well. However, for now, we are actually operating this application on the basis of this menu, which only runs with a command prompt. But now we also need to learn how to actually have a front end for our application, because obviously users are not going to use your application using the command prompt. They actually need a user interface using which they could interact with that user interface and get the student data, update data, delete data, so on and so forth. So in the next lecture, let's go ahead and let's build a front end for this application using Tkinter, and let's connect this database code with the Tkinter code. So let's learn how that could be performed in the next one. In this particular lecture, let's go ahead and let's create a user interface for our database application. So right now, the way in which we are actually running our application is we are running it through this particular command prompt right here, but we don't want this kind of an interface because obviously users are going to expect a window or a web application whenever you want to use a specific app. So in order to do that, we'll go ahead and we'll make use of Tkinter to design the front end for our application, which kind of creates a window. And all of these actions which we are now performing through the command prompt could then be performed using a Tkinter window. So in order to design that particular application, I'll go back to the code here. And a better way to kind of write the code for this would be to go ahead and create a new file. And first of all, create the user interface from scratch and then include this code in that particular file. Now make a note that we will also be modifying these functions as well. So therefore, modifying them in place here, it's actually better if we actually go ahead, create a brand new project and then have some of this code over here in that particular new project. So let's go ahead and let's create a new file and let's call it as demo1.py. This is not a proper naming convention, but you could say that this is the version 1 of our application. All right. So in this particular file, first of all, we will go ahead and build a purely Tkinter based application, which is not going to contain any code for the databases. So let's go ahead and let's start building that. So first of all, you have to go ahead and create a basic Tkinter window. So here I would say from Tkinter import star, which is to import everything from the Tkinter package. And then let's go ahead and let's create the main window. So I could say root equals tk. This creates the main root window for us. We could set the title for this window as well. So I would say root.title. Let's set the title as student management system. Now, once this window is created, you actually have to create a loop for this one. So as long as this loop executes, the window is going to stay there on your screen. So here I would say root.main loop. Let's save this code and see if it works. So I'll go back to the terminal here. Let's run this code by saying python 3 demo1.py. And if I run this, as you can see, we got a plain simple window right up over here. Now, on this particular window, we need to add the features which allow the user to create a table, insert data, read data, update data, and delete data. So the most important operation which we will be performing using this window is to go ahead and accept some data from the user about the students. So in order to accept all of that data here, we actually need to have the entry fields or input fields here, using which the users could actually enter the name, the other information, so on and so forth. So in terms of Tkinter, here we need labels and entries. And instead of placing those labels and entries directly on this window, we'll go ahead and first create a frame and then place the frame on this window and then place the labels and entries on that particular frame. So let's go ahead and let's do that. So I'll close this, go back to the code here. So first of all, I'll go ahead and I'll create a frame here. So I could say frame equals, and this is going to be label frame. So label frame is something in Tkinter which allows you to place labels and entries on top of it. So here we want to say that this label frame needs to belong to the root window. Then we could also add some text to this particular label frame as well. So let's say I want to set the text to student data because we are accepting student data there. And then once you have this frame, you could either use a grid or pack to place this particular frame onto the Tkinter window. So right now what we would do is we would actually use the grid layout manager to place this frame onto the window. So here I would say frame dot grid, and then you need to simply specify the row number and column number. So I would say I want to place it on the row number 0 and column number 0. And then after this, I could also set the padding on this one as well. So here I would say I want the padding on the x-axis to be 10 and padding on the y-axis to be 10 as well. And after that, you could also set the alignment of this particular frame as well. So in order to set the alignment, I would say sticky equals EW. So this sticky parameter actually allows us to set the parameter, and EW over here stands for east and west. So you basically want to make this label stretch from left hand side to the right hand side. So the east is on the right, west is on the left. So this actually ensures that the label frame actually stretches from left to right. So once we have set the alignment, let's see if the label is now added. So I'll go ahead, run this. And as you can see, the label does not show up over here. So let's now go ahead and add some labels and entries onto that particular frame. So let's go ahead, go back to the code here. Let's create a label for accepting the name. So here I would say label, and let's directly create this label here. So instead of saying label underscore name or name label equals to this, instead of that, let's directly create the label. Let's place it onto the frame. So remember that you don't have to pass in root here because we are not placing the label on the window, but instead we are actually placing it on the frame. So here I would say frame, which has just been created here. And after this, let's give it some text as name. And then let's directly add this label onto the grid. So here I would say dot grid. And then let's pass in the row number as 0 and column number as 0. Now you might think that, all right, we are using row 0 and column 0 for this frame, and we are using the same exact row and column parameters for the label as well. How is that possible? So you need to remember that whenever we are placing a frame, we are actually placing this frame on row number 0 and column number 0 of the root window. However, in case of this label, we are actually placing this label onto the frame, and henceforth this row 0 and column 0 are the rows and columns of this frame and not of the main window. So that's the difference between them. So once we have placed it in there, you could also go ahead and set the padding on this one as well. So let's say the padding on the x-axis is 2, and you could also set the alignment for this as well. So you want to align the label to the left and you want to align the entry to the right. So here I could say sticky equals, let's say W, which is west for left. So once this label is added, let's also go ahead and create an entry as well. So you cannot directly go ahead and create an entry over here like that, because we also need to refer to this entry in the later part of the code as well. So therefore you have to say name underscore entry equals entry. And then over here, we want to add the entry onto the frame. So I'll pass in frame here. And then I would say name entry dot grid to add it to the frame, and then set the row number as 0. So this entry is going to be for this label, which is name label. So the row number is going to be the same. However, the column number is going to be 1, as we want to place it next to the label. So column is 1. Let's also set the padding on the y-axis to 2, and then set the alignment using the sticky parameter and make it span from left to right. So EW. So let's see if that has been added. So I'll go ahead, run this. And as you can see, now here we have the frame added. So this entire thing right here is the frame. And inside the frame, we also have the label and the entry. So we have added one entry and one label here. Now similar to this, we also need to have labels for address, age, and phone number. So let's go ahead and let's quickly add them. So adding those entries is going to be a lot simpler, as we could just go ahead and copy the same code as we have over here. So let's copy this. Let's paste it 1, 2, and 3 times. Now the first one is going to be for name. The next label is going to be for address. So let's change the label to address. We simply have to change the row number here to 1. The column number remains the same. And then instead of name entry, I have to say address entry. This one is going to be address entry. And then over here, the row number is going to be 1, column is going to remain the same. All right, so now let's change this to age, as the next thing which we want to accept is the age. Let's change the row number to 2, column number remains the same. This is going to be an entry for age. This is going to be an entry for age as well. Row number is going to be 2, column number remains the same. Rest of the things remains the same. All right, now let's add the last one for phone number. The row number is going to be 3. This is going to be phone entry. Let's change this one to phone entry as well. Row number is again going to be 3, and that's it. Now let's save this code and see if all the entries are created. So I'll run this, and as you can see, name, age, address, phone number are now being accepted from here. So make sure that you don't do any mistake while you're copying and pasting code, because there's a maximum chance that you'll commit a mistake here. So once you have these labels up over here, the last thing which you need to do here is that you need to add a button at the end of the interface which actually submits this particular data. So in the next lecture, let's go ahead and let's create those buttons which are going to be used for performing those operations of creating a table, adding this data to the database, updating data, so on and so forth. So let's create those buttons in the next one. In this lecture, let's go ahead and let's add the buttons up over here for adding this data. So in order to create those buttons or add those buttons here, first of all, we'll create a new frame which is going to hold all of those buttons. So let's go ahead and after creating all of those labels, let's create a new frame called as button frame. So here I would create a button frame. This is going to be a regular frame and not a label frame. So I would say frame here. And this frame needs to belong to the root window. And after creating this, let's add this frame onto the main window. So here I would say button frame dot, we'll use the grid layout manager. And remember that this particular frame which we have up over here, we have placed this on row number 0 and column number 0. So we will place this one on row number 1. So row equals 1 and column is going to be 0. And let's also set the padding y as well, because we don't want to place this right next to the entries which we have created. So here I would say padding on the y-axis is going to be 5. And let's also make this sticky, and let's also set the alignment to east-west. So once we have this particular frame, let's now create some buttons and add those buttons to the frame. So here I'll create a button, and this button is going to be for, let's say, inserting data. So here I would say this button needs to be on the button frame which we have created. The text on this button would be add data. Then in order to add this onto the button frame, I'll use the grid layout manager. So dot grid. And then I would set the row to 0 and column to 0. So remember that these rows and columns are of the button frame which we have created. So row equals 0 and column equals 0. Let's also set the padding on the x-axis to 5, and that's it. So now if I go back here and run this code, as you can see, this add data button is added up over here. However, our original application also had options for creating the table, inserting data, which is in this case adding data, read data, update data, and delete data. That means we also need to have buttons for all of those other options as well. So here, let's go ahead, go back to the code, and let's also create a couple more buttons for the other options. So I'll simply copy this, paste it over here a couple times. After add data, let's also have an option for creating table as well. So here, let's change the first option to create table. Then let's keep this as add data. This one is going to be for updating data. So update data. And then we need to have delete data. So I guess that covers all the options. So creating table, add data, update data, delete data. We don't need exit because we have this cross sign on our window. Then we also don't need to have the option for reading data as well because we want to automatically fetch the data from the database and then display it up over here. Alright, so after adding those buttons, we also need to make sure that we need to change the row and column numbers here. So we want to place all of those buttons on a single row but on different columns. So let's change the column numbers here to 1, 2, and 3. Let's save this code and let's see how this looks like. So as you can see, this is what our application currently looks like. So here we have the option for accepting the data. Then over here we have buttons which define what exactly we need to do with that particular data. And then over here, we are going to take all of the data from the database and display it up over here in some kind of a view. So in the next lecture, let's go ahead and let's create a view here, which actually fetches all the data from the database and displays it up over here. And also whenever we go ahead and add a new set of data, that data is going to be added to the database. And whenever some data in the database changes, this view is automatically going to be updated. So let's design that functionality in the next lecture. In this lecture, let's go ahead and let's add a view to our application to display all the database data. So the view which we will be adding up over here is called as a Treeview, which actually allows us to place the database data in terms of rows and columns. So now the question is, how exactly are you going to add this Treeview? So let's go back to the code here. And just as we have a frame for the button and for the labels, let's also go ahead and let's create a frame for the tree as well. So let's call that particular frame as tree_frame. This is going to be a regular frame. It's going to belong to the root window. And now let's add this tree frame using the grid layout manager. So treeframe.grid, we have to place it on row number 2. So row equals 2, column equals 0. Let's add some padding over here as well. So pad x is going to be 10. And let's make this span the entire direction. So for example, we want to make it span from top to bottom and from left to right. So here I would set the sticky of this one to north, south, east, and west. Alright, so this actually creates the frame for the tree view. And now let's create the actual tree view. So to create a tree view here, I would say tree equals. And then in order to use the tree view is actually present in the TTK module. So here from Tkinter, I'll import the TTK module. So import TTK. Here, I would say TTK.TreeView. So this actually allows us to go ahead and make use of the TreeView class and create an object out of it. And here we could pass in a couple of parameters. So we want to create this tree view and we want to make this tree view belong to this tree frame which we have just created. So here I'll pass in tree frame here. So remember that you could also pass in root here if you actually want to add this tree view directly to the root window. But since we have created this tree frame here, we'll pass that here. So let's add this particular tree view. So we won't be using any kind of grid layout manager here. Instead, we'll directly use pack. So here we'll say tree.pack. Once this thing is done, let's save this code and let's see if that tree view is added. So if I run this, all right, so there's a slight mistake here, and that is this v should be in small letters. So if I go ahead and run this, as you can see now, this tree view up over here is added. So this tree view right here is currently empty. And also you need to understand that this tree view can contain thousands of records right here. Now obviously if it has thousands of records, then we cannot go ahead and infinitely increase the size of this window. Therefore we also have to go ahead and create a scroll bar up over here. So let's create a scroll bar for this particular tree view. So let's go back to our code here. And right after we have created this tree frame, let's create a scroll bar. So here I would call this thing as tree underscore scroll. And in order to create the scroll bar, I'll use the scroll bar class which we have. So scroll bar. And then over here, we need to say that this actually needs to be added onto the tree frame. So here I'll pass in tree frame. All right, so once the scroll bar is created, let's add it onto the window. So here I'll say tree scroll dot pack. And then we also could mention the position where exactly the scroll bar should be placed. So let's say we want the scroll bar to be present on the right of the tree view. So here I would say, all right, the side is going to be right. So make sure that you specify right in capitals. And also I want this to span the entire x-axis. So I'll set the fill of this one to Y. All right, so let's see if the scroll bar has now been added. So let's go back here. Let's close the previous window, run this code. And as you can see, the scroll bar is now added up over here. However, if I now try to go ahead and kind of scroll by dragging this won't work. That's because we now need to attach this particular scroll bar with this particular tree view which we have here. So in order to attach them, what we could do is when we create this tree view right here, you could actually pass in the tree scroll up over here. So here you say, all right, Y scroll, which means whenever we scroll on the Y axis, so we say Y scroll command is going to be tree scroll dot set. So what this does is that it actually allows us to link the scroll bar which we have created with the tree view which we have up over here. And this particular set method of the scroll bar is actually used to update the scroll bar's position when the tree view gets scrolled. So let's see if that actually makes any difference. So if I go ahead run this, now as you can see, we cannot scroll the scroll bar, and the thing which we have on the scroll bar which we drag, it disappeared from here. That's because this particular tree view does not have any kind of data. So when we go ahead and populate this particular tree view, the scroll bar is going to appear and that scroll bar is going to be fully functional. Now, let's go ahead and let's also understand how the data is going to be filled up over here. So this is going to contain all the data in the row and column format. So student 1 is going to be listed here. At the bottom of that, we have student 2, student 3, so on and so forth. So we should also be able to go ahead and select that particular student data from here. And in order to select that particular data, we have to set the select mode on this particular tree view. And in order to specify that particular select mode, here I simply have to say select mode equals, and here I'll set it to browse. And what this select mode equals browse means is that, let's say if you have multiple entries there, when we set the select mode to browse, that means we could select one item at a time or one student at a time in this case. So once this thing is done, now everything is pretty much added. But now we also need to go ahead and configure this particular tree scroll or the scroll bar here. So that means now we have the tree scroll and we have the tree view. But whenever we scroll the scroll bar, we also want to change or update the values inside the tree view as well. So in order to do that, over here I need to say tree scroll dot config, and I want to say that the command is going to be tree dot y view. So once this is set, we are pretty much good to go, and here our tree view is ready. Now the next thing which we need to do even before populating this particular tree view is that we need to add header columns to this particular tree view. So the header columns are nothing but they're kind of like the attributes which we want to display here. So for example, we need to say that, all right, these are the names of the students. This is the address, number, and age. So in order to denote that, we need to have header columns here. So in the next lecture, let's go ahead and let's learn how to add those header columns onto our tree view. In this lecture, let's go ahead and let's learn how to add headers over here to this particular tree view right here. So the data in the tree view is going to be represented in terms of rows and columns, wherein each row is going to represent a single student and each column is going to represent the attribute of that student. So here inside this tree view, we want to set all the columns to be equal to the different attributes the student actually has. So the student has the student ID, name, address, age, and number. So we want to set the tree's columns to those specific attributes. So let's go ahead and let's do that real quick. So let's go back to the code here and let's first go ahead and define the columns for the tree. So here I would say trees columns, so tree of columns. And here we'll define all of those columns in terms of tuples. So here I would say student underscore ID is going to be our first column. Then we want to have a column for name. Then we want the column for address, and then we want to have one for age, and the last one for number. So once we have defined all of those columns over here on the tree, let's see if they are going to be displayed. So I'll go back here and rerun this code one more time. And as you can see, even though the columns are not displayed here, but it actually went ahead and created this particular space for displaying all of those attributes right here, and that's exactly what we want as well. Now what we could do is we could configure these columns which we have. So by configuration, I mean we could go ahead and set the actual text on these one, and then we could also go ahead and kind of align it and set its width as well. So let's do that up over here. So I'll go back to the code here, and inside this code we have to set two things. First of all, we have to set the columns itself, or configure the columns itself, and then we also want to configure their headings as well. So let's first go ahead and let's configure the columns. So here I would say tree.column, and we'll start from the very first column, so which is column number 0. So in a tree view, the column number 0 is used to define a hierarchical structure, but since our data does not have hierarchical structure, it's a plain simple data, what we could do is we could set the column number 0 to invisible, and in order to set that, I have to say the column number 0, I would have to set the width of this one to 0 since I want to make it invisible, and then after this I also want to set the stretch on this one to no. So this kind of makes the column number 0 as invisible, and then we are going to start from the first column, and we are going to set the first column to the student ID which we have up over here. So here I could say tree.column. So this automatically takes the next column. This needs to be student ID column. And then we also want to align it to the center. So here I would say the anchor for this one is going to be center. And then I also want to set the width of this column as well. Now since student ID is a number, and in our case this is a single number, I'll set the width of this thing to 80. Let's also set the configuration for all the other columns like name, address, age, and number. So I'll copy this. So this one is going to be for name. So I would say name. This one is going to be for address. And this one is going to be for age. And the last one is going to be for number. Let's simply go ahead and change the widths on these things. So this is going to be, let's say 120, since the name is going to be a bit larger. Same is the case for the address. Age is going to be a smaller value, so let's set it to 50, and the last one is going to be number. Let's set it to 120 as well. So this actually configures all the columns, but right now we do not have any kind of data in the columns because obviously we have not fetched any kind of data from the database. So now let's go ahead and let's configure the headings. So in order to configure the headings of a tree view, we say tree.heading. Let's configure the first heading to student_ID. And then we have to specify the text which we want to display on that particular column heading. So here I would say text is going to be equal to, in parentheses, ID. And then we could also set the anchor on this one. So here I would say anchor is going to be center. So let's also add the headings for the other fields as well, such as name, address, age, and number. So this one is going to be name, this one is going to be address, this one is going to be age, this one is going to be number. Let's also change the text of these one. So this one is going to be name, address, age, and last one is going to be number or phone number. All right. So now this actually configures the columns, which is going to contain the actual data, and the heading for those columns as well. So now if I go back here and if I run this code, all right, we have an error here because I guess I have misspelled stretch. So I always forget the T inside the stretch. So I always forget the silent T which we have in stretch. And once we fix that, if I run this code, as you can see, now we have all the columns set up over here for ID, name, address, age, and phone number. So this kind of makes our application look complete. However, right now we have only designed the user interface for our application, and we are yet to populate our application with some data. So in the next lecture, let's go ahead and let's start writing the SQL code over here in order to fetch the data from the database and then populate this particular tree view with the available data. So let's learn how to perform that in the next one. In this lecture, let's go ahead and let's learn how to fetch the data from the database and display that data up over here inside this Treeview. So in order to fetch data from the database, we first have to write in SQL queries, but as you know, in our code, we do not have any kind of SQL query at all as of now. So the very first thing which we need to do is we need to go back to the code which we had written in the previous lectures, which was this code right here. And we have to make use of this particular code in order to kind of go ahead and make a database connection and fetch all the data from the database. So we won't be using this code directly from here over here, but instead we will use some bits and pieces from this code over here inside demo1.py. So let's first understand the flow of actions that has to take place in order to get the data from the database and then display that data inside this Treeview which we have. So the very first thing which we have to do is we have to establish a connection to the database, and after establishing a connection we have to execute a command which is select star from students. And once we have executed that particular command, then we have to take all the rows which are fetched from the database and then add those particular rows to this Treeview which we have up over here. Now obviously we could directly go ahead and start writing the code for doing that right up over here. However, there's one more thing which we need to take care of, and that is we have to make that particular code clean. So what exactly do I mean by making the code clean? So if you go to the previous file right here, you might have noticed that in every method which we have up over here, in every single method, the code for establishing the connection with the database has been repeated. So as you can see, inside the create table method, we have created this particular connection object. Then we have the cursor, then we have executed the query on the cursor, then we are committing those changes, closing the connection. So we have almost done the same thing in each method which we have here, and that is repeating a lot of code. So what we would do now here is that we'll take all the common parts which we have. So the parts of creating a connection object, the part of creating a cursor, then taking that cursor, executing a query, so on and so forth. And then we will create one single function out of those particular parts so that our code won't be repeated multiple times. So let's go ahead and let's start doing that right up over here. So we'll write those functions at the very top, and at the bottom we are going to have all the Tkinter code right up over here. So we won't be directly copying and pasting the code from here. We will just use this as a reference. All right. So here, what we will do now is we'll actually create a new function called as a run query. And the job of this run query function would be to go ahead and execute some kind of a SQL query. So here, let's create a function called as run_query. And now this function is going to accept two things. So whenever we are running a SQL query, there are usually two things to a SQL query. So first is obviously the query itself. So for example, we have this query like insert into students. And then the next thing which we have in here are the parameters which we need to insert, update, or delete. So there are two things to a query. One is the query itself and the next one is the parameters. So here inside this particular run query function, we want to be able to accept a query. And along with this, we also want to accept the parameters. So I would say parameters. Now the parameters which we wish to accept here, this could be in form of a list. However, we'll explicitly mention those parameters as a tuple, and that's because whenever you actually have accepted the parameters here, they actually need to be in form of a tuple. So as you can see inside this particular SQL query, the parameters which we have up over here are in form of a tuple. So here, in order to mention that we want to accept this in a tuple, I'll say parameters equal to this empty pair of brackets. So this signifies that the parameters are going to be in form of a tuple. All right. So here, whenever you want to run a SQL query, you first obviously have to go ahead and establish a connection with a database. So for establishing that connection, you need to have a connection object. So let's go back to this code right here and take this connection object from the create table method. And let's also go ahead and get the code for creating that particular cursor as well. So I'll copy this, paste it up over here, make sure that you have proper indentation here. Now this query which we will run here, it's actually going to provide us with a result. So let's save that result into a variable called as query_result. And for now, I'll set this variable to none, because obviously when we have not ran any query, this has to be none. So now here is where we will go ahead and execute the query which is being passed here. But even before executing this query, we need to understand that there's a high chance that that query might fail. And whenever that query fails, we don't want our program to crash. And henceforth, in order to avoid the program from breaking, here I'll include that particular code in a try block. So inside the try block, I would say, all right, now we have the cursor. So using the cursor, I could now execute this query. So here I could say cursor dot execute, and then I simply have to execute the query with the parameters passed here. So that's exactly what is being done here as well. So if you actually take a look at one of the methods here, which is this method right here, we have the SQL query passed here, and then we are passing in the parameters right after the SQL query to the execute method. So that's exactly what we need to do over here as well. So here I would say cursor.execute, execute the SQL query. So I'll pass in query here and then the parameters. So after executing this query will give us back some kind of a result. So if you have some query like the select star from students, then it's going to give us back some kind of result. However, certain queries, for example, let's say delete data or insert data, they are not going to give you any kind of result. So whenever you have select inside the query, that's actually going to give you a result, and rest of the queries like update, delete, so on and so forth, they are not going to give you any kind of a result. So therefore here I would say if the query dot lower, so we kind of convert the entire query to a lowercase, and we use the starts with method. So the starts with method checks if a particular string starts with some other string. So here we want to check if a particular string actually starts with select. So that means if it's a select query, then we wish to go ahead and fetch all the rows from that particular result. So here I would say if this is the case, in that case I want to go ahead and I want to take the cursor and fetch all the records from it. So cursor.fetch all. Now let's save the result of this particular method inside this query result variable which we have just created. So query result equals this. So this is what needs to happen whenever the query actually is a select query. And then we'll exit out of the if loop and then simply commit the changes. So con.commit. So if that is the case, then this should happen. So once we have this try block, we now also need to have the except block which actually handles the exception. So here I would say except, and inside the except block here, I'll accept a connection which is a psycop-g2 error. So whenever there's an error with the query, it's going to cause an exception which would be a psycop-g2 error. So here I would say psycop-g2 dot error as e. And over here, I simply need to log the error message onto the console or onto our application. So we don't have any kind of space on the application. So I'll actually create a message box and display that error on the message box. So here I would say message box dot show error, and the error would be database error. All right, let's actually convert this error message into a string so that it would be displayed. So now after the try and except block, let's also have a finally block, and inside the finally block we close the cursor and we close the connection. So cursor dot close and then connection dot close. And then the final thing which we want to do here is that whenever we run a query, we basically want to return this particular query result which we have. So over here, after the finally block, let's have a return statement as well, and then return the query result. And make sure that whenever you're writing this function, this particular indentation is correct, or else your code is not going to work well. So now once this run query function is complete, in the next lecture, let's go ahead and let's make use of this function to execute the select star from students query. So let's learn how exactly that could be done in the next one. Now once we have this particular function for running SQL queries, let's go ahead and make use of this to basically query the database so that the tree view could be populated. So now the way in which we are going to populate the tree view is that whenever we go ahead and run this code for the very first time, we want to execute a particular function, and that function would be called as a refresh Treeview. So what that refresh Treeview function would do is that it would go ahead and fetch all the new data from the database and then populate the Treeview which we have. So let's create that particular function right after the run query function. So here I'll create a function called as refresh Treeview. And the reason for naming this thing as refresh Treeview is because it kind of refreshes the data every time the function is called. So over here, what we simply have to do first is we have to call this run query method or function. And then to this, we need to pass in the query, which is select star from students. So here, let's do that. So I'll say run query. And over here, we need to pass in two things, the query and the parameters. So let's pass in the query here. So I'll create a string here and say select star from students. Make sure to add a semicolon over here as well. And now as the select statement is not going to have any parameter, we are going to leave it as empty because this parameter field is optional. So after this, this particular run query, as I earlier mentioned, returns a query result. So once it returns that query result, let's save this into a variable called as, let's say, records. So here I'll say records equals run query. Now these records are going to be nothing but they are going to be student rows. So then what we have to do is once we have those student rows, we simply have to loop through every single row which we have. So here I would say for every single record in the records list which we have, we then want to go ahead and take every single record and then insert it inside the tree view which we have. So the tree view which we have here is called as tree. So in order to insert those particular rows inside this tree, I simply have to say inside this for loop tree dot insert, and then over here the first parameter is going to be an empty string, then end, and then over here mention the values as nothing but the single record which we have. So this is going to loop through multiple records or multiple rows which are available. Then it's going to take those rows and insert it into the tree view which we have. So let's see if this actually would work. So I'll go ahead, save this, go back over here to the app, close this, get back to the terminal, run this code. And right now it won't work because we have created the function, but we also need to call this function as well. So the question is, where exactly would you call it? So you need to call it at the very end, but right before the main loop. So here, refresh Treeview, and this time hopefully it would work. So I'll run this, and we again have an error here which says scop g2 is not defined. So we have used scop g2 here while making the connection, but we forgot to import that. So let's quickly import that up over here. So import scop g2. Let's run this one more time. And as you can see, the app is up and running, and we do have these particular records displayed up over here. However, there's one important piece of code which we need to add here. And that is, let's suppose you actually run this particular method somewhere else as well. So for example, this particular refresh Treeview method is not just executed when the application first loads, but you also have to run this whenever you go ahead and insert some data into the database. So let's see what happens if this is repeated twice. So if I kind of call this twice, now what happens is it's going to fetch the data one more time, and it's going to add it to this particular table right here. So this actually fetches the data and then reinitializes this tree view twice. Therefore, now we are going to have duplicate entries. So what we have to do is, whenever we call this particular function, we first have to make sure that the table which we have up over here, or the tree view which we have here, should be completely empty. So in order to ensure that, what you could do is you could go inside the function which is refresh tree view, and even before executing the SQL query, you could actually go ahead and write the code to clear the current items if they are actually present in the tree view. So here, a loop through every single item inside the tree view. So I would say for every single item in the tree view, so in order to get the items inside a tree view, I would say tree dot get underscore children. So this get underscore children method on a tree view is going to give us all the rows which are present in the tree view. And then we want to loop through every single item and then delete that item. So from tree, we want to delete the item, and that's it. Now watch what happens even if we call this particular refresh Treeview method twice. So this time I could go ahead, close this, and even if I run this code now, as you can see, the data is not repeated here because the previous data has now been deleted. That means this is working absolutely fine, and you could actually make use of the update Treeview method inside other functions as well. Alright, so once this thing is done, in the next lecture onwards, let's go ahead and let's implement the other features of our application, such as let's make the insert data or add data method functional so that whenever we add some data here and click on add data, that data should be added to the database, and it should also be refetched and displayed up over here inside this particular tree view. So let's learn how exactly that could be done in the next one. In this lecture, let's go ahead and let's make this functionality work. So first of all, we'll work on the add data functionality. So whenever we enter some data here and click on add data, the database should be updated with those values. So the question is, how exactly would you do that? So basically we want to perform the insert data function whenever we say we want to add data. So let's go ahead and let's define a function for that. So let's go after the refresh Treeview method or function and then create a new function called as insert underscore data. And inside this particular function, what we have to do is we have to execute the query. So we all know that to execute the query, we have the run query method. So let's first form that particular query here. So I could say query equals, and you don't have to write this particular query on your own. You could just go ahead, go inside a function right here, and then from here you could simply go ahead and copy this particular insert into students query which we have up over here inside the insert data function. So I'll copy it from the start to the end along with the parameters as well. So I'll pass in that up over here. And now this particular query is absolutely fine, but now it also contains those parameter values as well in form of a tuple. So we don't want those particular values for now because we are actually getting them from the Tkinter entry fields. So let's get rid of them. And here, let's go ahead and let's create our very own parameters. So we want to get those parameters like name, address, and age from the Tkinter entries. So I'll create a new tuple here, and instead of saying a name, address, age, so on and so forth, let's get those from the entry fields which we have. So first we have to get the data which is actually entered inside this name entry field. So in order to get access to the name entry field, that field is named as name entry. So I'll simply go ahead and say name entry, and in order to get the data entered by the user there, I would say .get. So this gives us our very first parameter, which is name. Now we have to do the same thing for address, age, and number. So now let's get the address entry. So I would say address entry.get, give a comma, let's get the age entry. So age entry.get, and then finally we have the number entry. So I just want to make sure what we have named it. So for the number entry, we have called it as phone underscore entry. So let's get that up over here, phone entry dot get, and that's it. Now this kind of gives us all the parameter values, and we have stored those parameter values inside a tuple. So once we have the query and once we have the parameters, we then simply have to pass in the query and parameters to this created function, which is called as the run query function. So here I would say run query, pass in the query and the parameters. So once this thing is done, now the data would be inserted, but we kind of want to go ahead and give some kind of information to the user that, all right, the data has been added. So here I'll create a message box for showing information. So message box.showInfo, and then title of this one would say something like information, and then the message would be data inserted successfully. Now this will actually go ahead and insert the data inside the database. However, we also want to update the tree view as well, which is this view, so that when the new data is added, that newly added data should be displayed up over here. And therefore to do that, we'll again go ahead and call this refresh Treeview function. So let's go ahead and get rid of one call from here. Let's only have one call for the refresh Treeview function. And then let's call the other one inside this after the data has been added to the database. So now this will actually go ahead and refresh the Treeview with the newly added row. So let's see if that works. So I'll rerun this app one more time. Let's try adding a new student called as John. Address is, let's say, NY. Age is, let's say, 23. Phone number is, let's say, 777. If I go ahead and click on add data, all right, so obviously this won't work because we forgot a simple thing, that is to trigger the insert data function whenever we click that particular button. So in order to trigger that action, we have to go right up over here where the add data button is there. And over here, we also have to mention the function which needs to be triggered. So I'll give a comma and say the command would be insert data, and that's it. So again, have to rerun this app. Go back to the terminal, run this code. Name is John, New York, 23, 777. If I now say add data, all right, it's again giving us an error which says message box is not defined. So I guess we also forgot to add or import the message box. So over here, I would say from Tkinter import message box. Let's rerun this code. Let me re-enter the data. Let's click on add data. And now I'll get a message box here which says data inserted successfully. And now 2 entries for John is showing up over here. That's because in the previous attempt, even though the message box actually failed showing up, but the data was actually inserted into the database. So right now we have 2 entries for John. So let's say we want to delete one of the entries for John from here. So we simply have to select one of the entries and click on this particular delete data method. But right now the delete data button won't work because we have not yet added the delete data function. So let's go ahead and let's work on the delete data function in the next one. In this lecture, let's go ahead and let's implement the delete functionality. Now, deleting something just by using SQL was quite easy, where you go ahead and simply execute the delete command. And to that delete command, you simply pass in the ID of the row which you want to delete, and that used to delete everything. Now, that's exactly the same thing which we have to do here, but there are a few steps involved since we cannot pass in the ID manually. So technically what we have to implement here is that let's say if you want to delete this entry for John, you have to select this. And once it is selected, then you have to actually write the code to get this particular selected row. And from this selected row, then you have to get this particular ID which is currently being selected. And after extracting this ID, then you have to pass in that ID to the SQL statement and then order it to basically delete this particular row. So that's everything which you need to do. So let's implement this particular logic step by step. So let's get back to the code here and let's define a new function called as delete data. So I'll call that function here called as def delete underscore data. And then first of all, we have to go ahead and get the currently selected item because we are only concerned with that because we have to delete only that. So here to get the selected item, you first get the tree, and to get the selected item, you say tree.selection. So this selection method gives you the row. So you get the first item of this one. So you say selection of 0. Let's save this into something called as selected underscore item equals this. Now let's try to go ahead and let's try to print this up in the console and see what kind of data we actually get here. So here, let me print this thing up. So let me print the selected item. And in order to execute this, I want to execute this whenever we click the delete button. So let's go to the delete button which we have and associate a command with that. So here we have the delete data button. So let's say command is going to be equal to delete data. And that's it. Let me go ahead, rerun this one more time. And right now, let me select John here. And if I click on delete data, as you can see, you actually get this particular ID up over here. Now the question is, what exactly are you going to go ahead and do with this ID? So this particular ID is of this particular tree right here. And then once you have this particular ID of the selected item, you could actually extract the student ID, because this ID is of the entire row, and from the row you now want the ID of the student. So in order to get that, here I'll go ahead and go inside the delete data method, and here I would say get the tree item where the ID is the selected item. So tree.item, pass in the selected item here, and once we have the selected item, out of this I want to get the student ID, and the student ID is located at the 0th position or the first position. So here out of this I want to get the values, so I would say values of 0. So now this logic is a little bit complicated, so we won't go into how this works, but if you want to understand how this works, then just print this and then try printing the values and then try printing values of 0 so that you understand the underneath data structure. Alright, so this actually gives us the student ID. So let's save the student ID into a variable. And now once we have the student ID, we could pass the student ID to the SQL query. So here I'll go ahead and create a query. So the query would be simple, which is delete from students where the student underscore ID is going to be equal to %s. And then over here we want to pass in the parameters. So the parameter or parameters is going to be a tuple, and inside this tuple I'll simply pass in student ID. And also add a comma over here so as to signify that this is a tuple and it's not a function call. Alright, then we have to simply call the run query method, and to this pass in the query and the parameters, and that's it. Now the final thing which we want to do here is that we want to refresh the tree view so that the entry which is deleted is now removed. So refresh tree view and we are good to go. And even before that, let's actually display a message inside the message box saying that the data is deleted successfully. So message box dot show info information, and here I would say data deleted successfully. Alright, so let me make sure if everything is correct. So almost everything seems correct, and over here I guess this did not autocomplete. This should be this selected item, so this should be selected item, and that's it. So let's run this code one more time, and right now if I select this entry for John and click on delete data, it says data deleted successfully. If I click on OK, as you can see, the data for John is now gone. So let's try removing this data as well for Jake. So if I say delete data, the data won't be deleted right away because it will wait for this message box to disappear. So if I click on OK, now the data for that particular student is now gone. So this is how the delete functionality works. So the functionalities which are remaining are the update data functionality and the create table functionality. So let's implement them in the next one. In this lecture, let's go ahead and let's learn how to design the update functionality for our application. So in the previous example, we have implemented the delete functionality, and in the delete functionality, you simply select a row, and then when you click on delete data, that particular row gets deleted depending upon the ID of the selected row which we have up over here. So we want to now create the update functionality in a similar manner. So let's say, for example, if you want to update this particular row right here, in that particular case, what you should do is you should select that row, fill up the newly updated data which you want here, and then click on the update data button right here. So now let's go ahead and let's learn how to implement this. So to implement this, we have to do a couple of things which are similar to the delete data method right here. So inside the delete data, first of all, we go ahead and get the selected row, and from the selected row, we get the student ID which needs to be deleted. So we make use of the same logic in the update data as well. So here I would create a new function called as update data. And over here right away, let's copy the first two lines from here. And once we have those two lines, we basically get the ID of the student which we wish to update. And then we simply need to go ahead and write in the query for update. So let's write the SQL query for update here. So I would say query equals, and here I would say update students set the name equal to %s, set the address equal to %s as well, then set the age equal %s, then the number equal to %s. And we want to do all of this where the ID is going to be equal to the student ID, which we have up over here. So at the end of the query, I'm simply going to write in where the student underscore ID is going to be also %s. And we are actually going to substitute the values for %s inside the parameters. So now let's go ahead and let's fill up the parameters here. So obviously we are going to get the parameters from the entry fields which we have from here. So therefore what you could do is you could get the parameters from the insert data function. So let's get all of the parameters such as name, address, age, and phone number from here. Let me paste them over here. Now we have all the parameters here except for the student ID. So let's give a comma, and we are not going to get the student ID from the entry fields, but we are going to get it from here. So at the very end, let me specify the student ID. So once this is done, we are pretty much good to go. So now we just have to run the query along with the parameters. So let's use the run query function, pass in the query, pass in the parameters. And after passing them, let's now go ahead and let's add a message box here, which says that the data is updated. So let me copy the message box from here, paste it up over here, and data updated successfully. And then let's refresh the Treeview. So refresh Treeview, and that's it. And the final thing after this, which we need to do is we need to connect this particular update data method to the update button. So the update button is up over here. So let's add a command as update data, and that's it. So let me go ahead and rerun the app one more time. And over here, let's say I want to change the data for Robinson. So I'll select that, add the name as Rob. Let's update the address to London. Let's update the age to 20 and phone number to 888. If I click on update data, it says data updated successfully. Let me click OK. And now as you can see, the data has now been updated with all the new values which we have up over here. So this is how the update functionality works. So that means all of these three buttons are now functional, and now the only button which is not functional is to go ahead and create a table. Now obviously you don't have to kind of have this option here for creating the table because this particular create table function should automatically be invoked whenever there's no table created. But just as an example, I want to show you how this would work. So here, what I would do is I'll go back to the code and define a function called as create table. So here def create underscore table, and this is simply going to execute a SQL query. So the query in this case is going to be create table, and instead of just creating that table here, I'll add a statement called as if not exist, which means this is only going to create a table in case the table is already not present inside the database, because you obviously don't want duplicate tables created. So from here we could simply go ahead and take the rest of the query which we have from here, which is create table students. So I'll copy the rest of the part from here and then paste it up over here. So create table if not exist students, and then we have simply passed in the student ID, the name, address, the other fields which we want in the table, so on and so forth. And that's it. The only thing that needs to be done here is we need to call the run query function and pass in the query here, and then use a message box to say something like table has been created. So let me copy the message box from here, paste it up over here, and I would say something like table created. And then we simply have to refresh the Treeview. So this function is not as useful, but I just want to show you that you could also automate the process of creating database tables whenever you go ahead and click one of the buttons from your user interfaces. So you could go ahead and connect this to the create table button right up over here. So the command is going to be create table. So obviously you're not going to notice if I go ahead and execute this, because the table would be created in the backend. However, what you could do is you could go inside your PSQL shell and drop the current table by using the drop table command, and then try to create the table using the create table button which we have. So that's it for this particular project, and I hope you enjoyed building this particular student management system, which actually has all the features of creating data, reading data, updating data, and deleting data as well. And it also updates this particular user interface of our application real time. So that's it for this section, and I'll see you guys in a new one. Thank you.